Hello, everyone.
Hi,
Thank you
everybody.
for joining us for Livestream 4 of Posette 2025. We're your hosts, Thomas Monroe and Adam Wolk, and we are coming to you from New Zealand and Poland. And I'm going to start by giving a quick introduction for Adam. Adam and I actually go back a little bit. We met in 2019 at PGCon in Ottawa in Canada. And we found out we had a whole lot of different things in common. We're actually both involved in the BSD projects. Adam's involved in OpenBSD. I'm involved in FreeBSD. And we had a really interesting talk that day about the history of Postgres at Berkeley and the BSD license and the way that all of those things happened around the same time. It's a super interesting bit of history. Adam is an OpenBSD contributor. Aside from his work on Postgres and Citus and at Microsoft. And he's got a whole background in computer security. And he works now as a program manager for Postgres at Microsoft and does a lot of work around Citus and extensions. And his pathway into Microsoft is also, by coincidence, similar to mine. We both sort of came through the Citus route, the Citus acquisition.
Exactly.
Yeah,
like I didn't went through the acquisition, but I did like interview for the Citus team, and that was like my end goal.
Yeah. So, yeah, it turns out that we just had so many things in common. So it's great to be co-hosting a great lineup of speakers coming ahead, and yeah.
Yeah, and for Thomas, like you have a decade of experience with PostgreSQL itself, like 5 at EnterpriseDB, if I recall correctly, then another 5 at Microsoft, which is a heck of a long time, to be honest. And before that, you have a couple of decades in tech and web at financial industries. And by the way, we also shared that history, right? Because I also did core banking software in the past, and we had recently a brief chat on that privately. And you used all of the databases and all kind of Unixes in the past, right? So you're a FreeBSD contributor and committer.
Yeah.
So we share this passion. I'm actually sporting a BSD Now TV T-shirt. And you work on storage and file system bits, making PostgreSQL run faster on FreeBSD and exploring like database and operating system integrations. So you're also part of the PostgreSQL developer team here at Microsoft that works upstream with the project. You're also a committer on the PostgreSQL project, and you work with other major contributors, people from your team that directly contribute upstream to PostgreSQL. And I think that's amazing, and Charles later on will, I think, demo a lot of the work that your team is doing.
Cool.
Okay.
So take it
away. Yeah. So we meet today to run Posette, an event for Postgres. We have a great lineup. We have 42 talks in Posette 2025. 4 live streams. This is the 4th live stream, but don't worry if you missed all the previous ones or if they run in a time where you were asleep. These are all recorded. The recording will be available on YouTube with transcripts. Like there's a whole team doing a great job making sure that everything we bubble into the microphone right now is perfectly deciphered, so you can read it at your own leisure. We have a great lineup of hosts. Thomas?
Yeah. So at the same time as this is running, there's a Discord where where everybody can discuss what's happening on screen, talk about the talks, and hopefully talk to some of the speakers. So if you're interested in the hallway track of this online conference, don't forget to join that.
And maybe we show where you can find the hallway track on Discord. If I pull up my browser very briefly, So this is the Posette.com 2025 website. And you can see the live stream here I'm not playing it, so we don't get this weird effect of seeing an infinite copy of ourselves on the screen. But on the right, you can see a live chat, and this is the hallway track where you can join with this button, join Discord. It's a very quick setup. You will be able to join the chat, talk with the people. Now, since all the talks are pre-recorded, but a lot of the speakers come around during the whole conference, or at least for the playback of their own talk, so you can actually ask them questions, and if something piques your interest, you can get that straight information. And often, to be honest, often the hallway track is the best track to follow.
Cool.
Okay, so we can go back to our deck.
All right. Yeah, this whole conference is put together by the Postgres team at Microsoft to try and create. This began somewhere near the end of the COVID period as a way to run a conference that was all online, and it's still here and getting bigger every year. And there's lots of really interesting talks, and this is put together by Microsoft's Postgres team.
And with online conferences, we are happy to make this accessible virtually for anybody. Traveling to conferences is fun, but it takes resources, logistic, time. Not everybody can do this. And here we remove the boundaries. And we are actually a distributed team around the world, like the whole team that works here. So we feel the need to connect with people not only in person, but also in this format. Thomas?
Cool. So in common with with conferences that happen that you travel to, we have a code of conduct, and the basic idea is be friendly and welcoming and respectful and inclusive. So make sure you remember that when you're using the Discord channel and talking to people about the conference topics and anything else about Postgres. So.
We already mentioned that accessibility and captions are important to us. They will be present on all talks later, available in 16 languages on the recordings on YouTube. If you are live posting the event, please use the hashtag PosetteConf on Discord, LinkedIn, X, Blue Sky, Mastodon, or whatever platform of your choice. You can also follow us on the many socials. You can see them on screen right now. And there's a huge gratitude from us to all of the amazing speakers that are joining us this year. There's too many to mention by name in the short time we have before we kick this off into talks. And if you want to get an ultimate guide, you can go to aka.ms/posette-guide or scan the QR code to get a ultimate experience and roadmap for this event. There's 2 amazing keynotes, 18 core talks, 12 ecosystem talks, 10 Azure DB talks in total, which is an amazing lineup. And we mentioned the virtual hallway track. You can scan the code here, you go to the URL, or go to the website, as you saw before, directly, and kick it off from there. Or you're probably already there if you're watching us. And if you have questions for speakers, join the Discord. And there's Thomas.
All right. So make sure that you get involved in the feedback program when you're watching these talks. If you send feedback, you can receive swag. You can receive socks, for example. They're particularly cozy. I highly recommend those socks. I'm wearing them right now. So that's something that you can do. You can access by participating in the feedback for the conference. All right.
And complete surveys. After every talk, you have a chance to do a survey for the speaker. That's very important for the speakers because you improve with feedback. We have first-time speakers, multiple-time speakers, and it's nice to be inclusive.
Cool.
Okay, so let's look at the schedule for today. 11 talks today for all of us. And let's do the trailer maybe and see what's coming up.
Hi everyone, and welcome to the 4th year of Posette and event for Postgres. My name is Charles Feddersen. I'm the Director of Product Management for Postgres at Microsoft, and I'm pleased today to be able to tell you about all the things we're building in Postgres at Microsoft in 2025.
Hello everyone, I'm Marco Slot. I work at Crunchy Data, and I'm gonna talk about a journey we've been on for the past 18 months to build a Postgres data warehouse. So if you're interested in using Postgres for analytics, or you want to know more about what's possible using Postgres extensions, this will be a very interesting talk.
Hi, my name is Derk van Veen. I'm a database specialist at Azure, and I mainly work on a partitioning framework. So, of course, this talk is about partitioning. So if you're managing tables around 100 gigabytes and more, this is definitely the talk you want to see.
Hello, I'm Amit Langote. I work at Microsoft in its Postgres open source team. In this talk, I'm going to talk to you about how Postgres Executor interacts with modern CPU and how that impacts its OLAP query performance. I'll talk about a few things we've done to improve that, and then some architectural directions we could take in the future. So if you're interested in OLAP performance, please join me.
Hello there, everyone. I'm Michael John Peña. I'm a Microsoft MVP and MCT, Data and AI Director at Playtime Solutions. I'm here to talk about building enterprise RAG applications with Azure PostgreSQL. And if you're looking for something about embeddings, vector search, all things around LLMs, this is the right place for you.
Hello, everyone. My name is Péter Farkas. I'm the CEO and co-founder of FerretDB, which is an open source alternative to MongoDB. And today I'm going to talk about turning MongoDB into an open standard and implement it on Postgres. So if you're a MongoDB user, if you're a Postgres user, if you are both, then you might be interested in this presentation where we combine the power of these two database technologies.
Hi everyone, my name is Adam Wolk. I'm a Principal Technical Program Manager for PostgreSQL here at Microsoft. Today I'm going to tell you how to travel using row-level security with PostgreSQL and Citus. So grab a towel and join me if you want to learn how to use row-level security with your application.
Hello, I'm Ellyne and I work at marketing at DBTune. My talk is titled Setting Max Connection, Building Postgres User Groups that Bring People Together. I'm really excited to be here at Posette today. I'll be sharing some practical advice on how to create successful Postgres meetups. If you're interested in fostering thriving Postgres communities and creating interactive and fun small and large scale events, this talk is for you. Now let's get started.
Hi everyone, welcome to Posette Conference. I'm Rahila Syed. I work as a senior software engineer in Microsoft. Today I will be talking to you about monitoring in Postgres, and also will be explaining a design of monitoring feature in Postgres. This talk will be useful for developers and administrators who are looking to learn more about monitoring in Postgres.
Hello and good day, this is Jan Karremans. I head up sales in Cybertech, but I still think I have sufficient technical background to take you along on an interesting journey in securing Postgres with streaming replication. It is one of the hidden in plain sight cool features of Postgres that might just help you save the day.
Wow, that's a great lineup. And by the way, Mike on the hallway track mentions that at least something good came out of COVID, referring probably to the virtual nature of the conference itself. Okay, so next up, we have Charles Feddersen. Charles is actually a director of product management for PostgreSQL here in Azure. And I've seen Charles give similar talks before on live conferences like PGConf, and I had people coming over to the Microsoft booth saying that, wow, I didn't know Microsoft is contributing so much in back to the PostgreSQL community, both in events and in actual code contribution. And we have you and your team to thank about a lot of that. So I'm looking forward to Charles essentially in his next talk describing what type of work Microsoft is doing with and for PostgreSQL.
Exciting stuff.
Hi, everyone, and welcome to the 4th year of Posette, an event for Postgres. My name is Charles Pedersen. I'm the Director of Product Management for Postgres at Microsoft, and I'm pleased today to be able to tell you about all the things we're building in Postgres at Microsoft in 2025. Over the past few years, Microsoft has continued to invest more and more into open source Postgres. This includes both code that goes into the open source project and the investments that we're making to sponsor community events or hosting events as we do with Posette. We're pleased to be able to put on this virtual conference for the community, and we want to share some data on how Posette has evolved over the years. Posette stands for Postgres Open Source Ecosystem Talks, Training, and Education. And as we enter the 4th year of running this event, we're pleased to see such a strong response from the community. This year, we received 230 talk submissions, which is a 25% increase over last year, and content from the Posette 24 conference has been viewed over 42,000 times. Of course, conferences, even virtual ones, take a lot of work. And as we have an amazing team at Microsoft who make this event happen every year, I'd like to thank the 2025 Conference Organizing Committee of Aaron, Abe, Amu, Bilge, Jeremy, Linda, Pooja, and Teresa, who have done an exceptional job to develop and run this fantastic event. I'd also like to offer a huge thanks to our talk selection team. As I mentioned, this team was given the daunting task of working through 230 submissions and selecting down to only 40 talks for the conference, and I know there were far more than 40 great submissions that they wanted to accept. In early May, Claire Giordano published our annual blog covering all the Postgres work that we've done at Microsoft for the past 12 months. It's a massive aggregation of our work over the last year and encompasses investments in open source, the features we've shipped in the cloud in Azure Database for Postgres, and of course, the investments into the community. If you haven't taken the read, I encourage you to do so when you have some time. And if you don't have time, Copilot will do a great job summarizing it for you. You can get there quickly from aka.ms/blogpg at Microsoft. Now, Postgres 18 is coming a little later this year. And as with Postgres 17, Microsoft has been a significant contributor. To date, Microsoft engineers have made 456 pre-release commits to Postgres 18, and this includes work done solely by the committer, co-authored by the committer with somebody else, or committed on behalf of another author in the community who authored the patch. Let's take a look at some of the key contributions that Microsoft is making into Postgres 18. We'll start with asynchronous I/O, which has been a multi-version investment to incrementally add this complex feature. Postgres 18 adds significant new infrastructure to perform efficient file system I/O with modern operating system features. In Postgres 18, all read streams will now use true asynchronous I/O, and in future releases, other types of I/O, perhaps most notably writes, will also support async as well. The chart on the screen shows the relative improvement of Postgres 18 performance over a variety of functions using both local and cloud storage relative to Postgres 17, which is the baseline of 1, which here is effectively the y-axis. And you can see there are some significant performance improvements coming in Postgres 18. Now, we've contributed a bunch of performance improvements for query processing as well. And this includes patches to enhance memory management for materialized window aggregation, common table expressions. We've contributed patches to improve performance of hash group by and hash joins, and also the performance of fast path locking that reduces contention between Postgres sessions that obtain a large number of locks. And finally, we've contributed an optimization for group by performance with subplans and unique indexes. Currently, Postgres does not support native cloud-based authentication, and changes are required to support enterprise identity. In Postgres 18, our team contributed to bring OAuth 2.0 authentication to Postgres, allowing users to log into the database using secure token-based credentials from identity providers. This feature will enable third-party identity for Postgres while remaining more aligned to the upstream Postgres project. We've learned a lot from customers about bottlenecks they've encountered with table partitioning and co-authored patches in Postgres 18 to improve the performance based on these learnings. Almost everyone using partition tables will benefit from these improvements, and our initial benchmarks with 56 partitions show that the planner is now 3x faster in scenarios of thousands of partitions, and the benefits will be even greater. One of our favorite topics for everyone is vacuum, and one of the main items our team contributed to in Postgres 18 is enhancement to reduce the impact of aggressive vacuum. Now, aggressive vacuums can incur large amounts of extra I/O at the expense of workloads to reduce the cost of aggressive vacuums. This contribution enables Postgres 18 to eagerly scan all visible pages during normal vacuums with greater efficiency. And finally, moving on to multi-threading, I think most people know that Postgres currently utilizes a process-based architecture, and the topic for introducing threading has long been discussed in the community. Now, as Postgres is being applied to more demanding applications, multi-threading will enable PostgreSQL to run these events more effectively. Our team is working on some early groundworks that enable the future work to bring multi-threading to Postgres. Very early, but we're getting started. Now, switching gears, I'd like to talk about one of the major announcements we just made at the Microsoft Build Conference in May, where we announced the availability of an entirely new Postgres extension for VS Code. It's no secret that Postgres is the preferred database for building new apps, and its popularity is growing each year. We've spoken to so many developers who are building or occasionally just maintaining Postgres applications. And what we've learned and heard is that although Postgres is great, developers could definitely benefit from better tooling. Application developers tell us that they consistently break out of their flow from writing app code into specialized Postgres tools like pgadmin or a pSQL terminal, but they find this a little clunky and inefficient. So to help developers who are building in VS Code, we've released a new Postgres extension that works with any version of Postgres running anywhere. It's IntelliSense enabled, deeply integrated with Copilot, and free to download and get started today. And to give you a sense of some of the functionality, I've asked my friend Rob from our engineering team to do a quick whirlwind tour of just some of the new functionality. Take it away, Rob.
The extension allows me to quickly create a local instance of PostgreSQL inside a Docker container, allowing me to get started developing quickly. Or I can quickly connect to an existing Azure database for PostgreSQL flexible server directly from my Azure resources. With built-in Entra authentication, there's no need to store passwords locally. The extension seamlessly manages token refreshes, making secure password-free connections effortless. Once connected, I can browse database objects and launch an integrated query editor. The extension's IntelliSense helps me quickly find the right tables, views, and columns, and the formatter keeps my SQL tidy. After executing a query, I can browse the results in the results viewer, filter for column values, and export them directly to Excel, JSON, or CSV. The extension also lets me quickly open a pSQL terminal connected directly to my database, bringing the power of this popular Postgres tool to any database connection, including those using Entra authentication. Here I have a database that contains a sample dataset representing a DVD store. I select Chat with this database, bringing up a chat addressing our @pgsql copilot. The copilot has the full context of my database and can easily construct complex queries, execute them, and interpret their results. Here I ask about top revenue films per category over a period of time. Copilot has no problems answering my question directly. If I want to see how Copilot got the answer, I can go to the query history and find every query Copilot has executed against my database. This example demonstrates Copilot's Azure-specific capabilities when working with an Azure PostgreSQL instance. I can ask Copilot to describe my server's resources, check when the most recent backup occurred, and have it add the disk ANN extension to the allow list of extensions for my instance. Here, I have Copilot help me set up a disk ANN index on a table storing embeddings of archived paper abstracts. Copilot guides me through configuring disk ANN using the latest documentation and confirms the details before creating the index. The extension works great with any Postgres database, and even better with Azure. Whenever I want to spin up a new Azure database for PostgreSQL Server, I can do it directly from VS Code.
We've had a ton of positive feedback on this new extension, as well as an ever-growing backlog of features that developers would like us to deliver. We're going to continue to add new features fast and keep new versions rolling out, so stay tuned, and we'd love your feedback on this tool as well. Now, let's talk about AI. In May, we announced the general availability of Disk ANN, a state-of-the-art vector indexing algorithm developed by Microsoft Research and available on Azure Database for Postgres. Disk ANN offers exceptional performance and accuracy for similarity search tasks, making it a powerful choice for developers building high-scale generative AI and semantic search applications. Disk ANN significantly outperforms traditional vector index methods, such as HNSW or ivflat, in terms of both query latency and retrieval accuracy. In our performance tests, we found that Disk ANN outperforms HNSW under common workloads while maintaining higher query per second throughput and using less memory. We've also recently added a new feature called product quantization. One of the key innovations behind Disk ANN's performance is product quantization, or PQ, which compresses high-dimensional vectors into compact representations and significantly reduces the memory footprint. And by enabling more vectors to fit in memory, PQ minimizes I/O operations and enhances the overall throughput. And unlike other quantization approaches, PQ allows for efficient approximate nearest neighbor search with minimal accuracy degradation. Whether you're building RAG pipelines, recommendation systems, semantic search, or real-time personalization engines, developers can now leverage this powerful Disk ANN index directly in Azure Database for Postgres for building better apps. Now, semantic operators. Vector search is a fundamental requirement for modern Gen AI apps, and it enables these agents to provide proper business context by retrieving relevant pieces of information from the database. But it scratches the surface of what's possible. Semantic relationships between elements of data are not visible to vector search, and this is where the new semantic operators that we announced in May come in. These operators add semantic understanding directly into your database and bring the reasoning power of language models to your queries. The most generic operator is Azure AI Generate, which can generate arbitrary ChatGPT-style responses in SQL queries and be used to generate test data or generate structured output. Is true returns a Boolean, resolving a natural language statement into a binary outcome that can be used for filter conditions or joins. Extract is a powerful operator for unstructured to structured data conversion, and this operator can be used to extract semantic relationships hidden in your data and act upon them to bring additional intelligence to generative AI agents. And finally, rank is a highly accurate semantic ranking operator, which is effective at boosting the accuracy of vector search. Now, to give you a quick example of how these work, I've asked my friend Abe to provide a quick demo. Take it away, Abe.
Hey folks, my name is Abe Marbe, and I'm a PM on the Azure Postgres AI team. Today, I'll be using semantic operators to enrich shop content and improve queries in my e-commerce database. Semantic operators allow me to use large language models in SQL. For example, I can use Azure AI Generate to generate descriptions for each product based on its name. This is super useful, especially for test data generation. Next, I can use semantic operators to find semantic relationships in the data using natural language expressions. Here, Azure AI is true operator returns true when it finds reviews that mention a particular feature. Now that I've identified features mentioned in reviews, you can then use the extract operator to get the sentiment about this particular feature. In this case, we define sentiment as positive, negative, or neutral. Lastly, let's flip to the rank operator, and I'll show you how you can use Azure AI Rank for re-ranking in Azure Postgres to improve queries. Let's run a normal vector search query. The results seem a bit off. I asked for the highest playtime, and I know we have headphones with better playtime than this. Here's a version of the same query, but now with re-ranking using Azure AI Rank. Much better results. The top results are now much more relevant. Semantic operators are a powerful addition to your database. You can utilize, generate, is true, extract, and rank to greatly enhance the data in your database and improve query accuracy.
Thanks, Abe. We're incredibly excited about this new functionality and can't wait to see what application developers will be able to build with it. Now, when new technology waves such as AI come along, one of the largest challenges for everyone is learning how to apply it to real-world scenarios. To help with this, our team has developed 3 advanced solution accelerators that are designed to show how to build new AI apps using Azure Database for Postgres. The first one is Agentic Shop, which is a modern retail experience powered by multi-agent orchestration. It uses Llama Index, Mem0, pgvector, Discain, and our new semantic operators to deliver a dynamic and personalized shopping experience where each shopper gets custom layouts and AI-created content with memory of prior interactions driving smarter recommendations. It's a great example of how to build agentic systems using Postgres. The second one is to build your own copilot using Postgres. This one is a deep dive into building intelligent copilots using RAG, where it combines vector search, semantic re-ranking, and LangChain to deliver context-rich answers from structured and unstructured data, such as statements of work or invoices. And it also includes GraphRag using Apache Age for more complex knowledge grounding. And it's backed by a practical hands-on lab guide to help teams learn to deploy faster. And finally, there's Chat with Your Data in Postgres, which creates a natural language interface to your data using Azure OpenAI. Users can upload documents, index web pages, and query everything through a chat UI. It supports flexible RAG configurations and prompt engineering, which makes it a great starting point for teams experimenting. Let's now switch over and look how we can scale Postgres out. Elastic clusters are a new feature for Flexible Server, which enable modern applications to scale out across a cluster of Postgres servers without application layer sharding. Built on the open source Citus extension, Elastic clusters enable horizontal scaling of a database using either row or schema-based sharding, which makes it easy to manage large data sets using online rebalancing, tenant isolation to avoid these noisy neighbor scenarios. These clusters are well suited to applications that require high elasticity and scalable performance, where queries can either fan out or execute on a single node. Scenarios include multi-tenant SaaS applications, which can benefit from either schema or row-based sharding to spread tenants across a cluster, or microservice architectures where schema-based sharding enables independent scaling of different surfaces. Another great fit is IoT data processing, where row-based sharding can efficiently handle large-scale IoT workloads by distributing massive tables across multiple nodes. Now, the last topic I'd like to cover today is performance and how we're investing more in Azure Database for Postgres. So let's start with performance and scale. In the coming months, we'll introduce new V6 compute SKUs in GA from Azure that enable 192 vCores and up to 1.8 terabytes of memory. These servers not only increase the maximum number of cores and memories that the servers can deliver, but also improve the per core performance. This new infrastructure raises the bar for the scale of workloads that Flexible Server can support. For high availability and disaster recovery, we recently announced the general availability of on-demand backups to provide greater control over backup schedules, with retentions of up to 35 days. We've also enhanced point-in-time restore of backups to provide an RPO of up to 5 minutes. For security, we've released versionless customer keys in April to provide simplified management of encryption keys by eliminating the need to manage specific versions. And for improved manageability and monitoring, we've released task automation in late 2024 to reduce operational overhead by automating routine tasks like server start and stop, scaling, and cost notifications. Today, we now support over 70 monitoring metrics, and we're consistently adding new metrics based on customer feedback. Monitoring is integrated into any of Power BI, Grafana, or Azure Monitor, and Azure Postgres now supports over 70 extensions as well, including pgvector 0.8 for AI workloads, PostGIS for geospatial, and timescale for time series. The Azure AI extension I mentioned before integrates with Azure Machine Learning and OpenAI allowing enterprises to leverage AI models directly within Postgres for semantic search and anomaly detection. And finally, we've built new integrations to Microsoft Fabric to support mirroring from Postgres into OneLake for analytical scenarios. And we've also provided new transformations into the data flow so that you can add Postgres into your data integration pipelines. It's a great innovation into Fabric, and we think it's going to be a great way for you to make Fabric work with your existing Postgres implementations. Now, we've covered a lot, and we're working on so much more. At Microsoft, we're deeply committed to contributing to push the open source project forward into Postgres 18 and beyond. We're working on some of the largest multi-version features that are available in Postgres, and we're going to continue to push into new versions. And at the same time, we're continuing to innovate at a rapid pace in the cloud. And this is at both ends of the customer spectrum, from enterprises to developers. Over the next 6 months, you'll continue to see more scalability, security, and high availability improvements coming to Azure, while at the same time, we'll continue to invest in VS Code tooling and new AI capabilities that empower developers to build the next generation of apps more efficiently than ever. Thank you very much for your time today, and thank you again to the organizers of the conference. It is a packed agenda with exceptional speakers and amazing content. I'm looking forward to joining quite a few of the sessions myself. Thank you again, and enjoy the conference.
All right, wow. That is a mind-blowing amount of technology with Postgres at the center of it. And that's all stuff that you can use. A lot of that stuff is upstream in Postgres, and obviously there's a whole ecosystem around it, and it's pretty incredible. Don't forget,
we all benefit.
We do, and don't forget to go and fill in the survey. The title of the talk, Charles's talk, is what Microsoft is building for Postgres in 2025. You might get some socks. Next up, we have Marco Slot. We know Marco as one of the lead engineers from the Citus project, but today he's going to be talking about turning Postgres into a data warehouse. And I think Marco is in the Discord. If you want to ask him any questions during the talk, you might catch him.
The hallway track was pretty active during Charles's talk. Like, people were eating up the VS Code Copilot extension. And I did so, Marco, so I assume you can throw some questions at him as the talk is running.
Yeah. Very good. All right.
Hello, everyone. I'm Marco Slot. I work at Crunchy Data, and I'm going to talk about a journey we've been on for the past 18 months to build a Postgres data warehouse. So if you're interested in using Postgres for analytics, or you want to know more about what's possible using Postgres extensions, this will be a very interesting talk. Now, a lot of you might know me from my days in Citus. I've been working on Citus for most of the past 11 years. So it's a big chunk of my career. And when we started Citus, we were actually looking at going into the analytics space. At the time, you had Hadoop, and Spark SQL had just appeared. And we were thinking, oh, can you do distributed queries on large amounts of data using Postgres? But pretty quickly, it became apparent that it was more natural for us to go after workloads where Postgres was already a good fit, like software as a service workloads that needed to scale out. And also, these were real-time analytics workloads where you're writing a lot of events into the database and you're doing some pre-aggregation in the database and have a lot of queries on the pre-aggregated data. But it wasn't really a good fit for sort of more general analytics, business intelligence, where you combine data from lots of different sources and do transformations and complex queries across all the data. But still, a lot of the companies we talked to were actually looking for a Postgres data warehouse. It was just, we would have liked to build something like that for them, but it's also very hard. Because fundamentally, Postgres is an OLTP system. The database industry is sort of divided into these two factions, some smaller factions, but the two main factions are OLTP databases and OLAP databases. So these are different systems, different people. They don't talk to each other very much, but they do agree that you should use SQL, that you should have transactions. But everything else is a little bit different between these databases. So OLTP systems like Postgres, they focus on supporting a high rate of transactions, like small updates, update a single row, select 10 rows with very low response time and very high throughput. Whereas analytics databases, they don't necessarily handle many queries at the same time or queries at a very high rate. Instead, they focus on having a very high scan throughput. So scanning through lots and lots of data in a single query very quickly. And this is a very different kind of optimization problem. Like in OLTP, you want a very quick planner. In analytics, you want a query planner that can really find the best possible query plan. And if you start zooming in the details of these systems, they're really different at every level. But one of the most sort of talked about difference is the storage format. So OLTP systems generally use row-oriented storage. So the data is stored row 1, row 2, row 3, and then there is an index that you use to find a specific row or a small set of row. And the index only requires you to take a few steps, and that's very efficient for running queries that select by a unique key, for example. Analytics databases tend to use column-oriented storage. So values from the same column are stored together on disk, often in a compressed form, because maybe some columns only contain mostly zeros or some recurring strings. So it tends to compress pretty well. And then analytical queries, they often span many rows, but maybe not all of the columns. So in this case, you only have to read the columns that you actually use in the query. But the big performance differences between these systems partly come from how they execute queries. So a row-based system will typically take a row from storage, and then in the query is essentially a set of expressions like from the where clause and from the select clause and the aggregates. And so it will take that row, evaluate the first expression, the second expression, the third expression, take the second row, first expression, second expression, third expression. And all these expressions are a bunch of function calls that do a bunch of allocation. So there's a lot of CPU instructions associated simply with switching between different functions. Because of the allocations, your CPU cache might not be used very efficiently. And your CPU also has a hard time predicting what's next, because one of the ways CPUs speed up programs is by kind of already going into the next instruction before the previous one has started. So in column-oriented systems, what you can do is this vectorized execution. So there, the query engine takes a vector of values, an array of values, and the expressions are all implemented as loops. And so they do the same comparison on all values in the vectors. And outcomes may be a new vector with, let's say, the indexes of the rows that match the filter. And now this function call overhead almost goes away. You only switch between expressions once every, let's say, 2,000 rows. Your CPU has a better chance of guessing what's next. You keep the data in your CPU cache. And then also modern CPUs have these instructions that can process multiple values in a single instruction. And altogether, especially combined with parallelism, these databases can often be 10 or 100 and sometimes even more than 100 times faster than Postgres for analytical queries, which is pretty amazing, and it's also hard to scale against. But it's very hard to build a vectorized query engine, and there's also the fact that other parts of Postgres are not necessarily optimized for analytics. So you wouldn't want to put in all the effort of building a very good vectorized query engine and then find that it doesn't work well because Postgres is not architected for it. But of course, Postgres has one important superpower, which is it is extensible. So anything that Postgres is not good at, we can make it good at through extensions. A few years ago, it was not a good vector database, but now it's a great vector database because we have pgvector. It was not a distributed database, but then Citus made it a distributed database. And similarly, we can actually make it a good analytics database through extensions, but we do need a vectorized query engine. And over the past few years, we've seen the emergence of these embedded query engine. And I think DuckDB for our purpose is actually the most suitable one. It has a similar license to Postgres. It's targeting single machine. And its SQL dialect is actually derived from Postgres. It uses the parser library that's derived from the Postgres parser. And it also has extensions itself, kind of inspired by Postgres, which makes it more amendable to being integrated into different environments. So we can now feasibly build a data warehouse with DuckDB, this vectorized query engine, to speed up the analytical queries and use extensibility to integrate it into Postgres. Because one of the things that Postgres allows an extension to do is intercept all of the incoming user commands at different points. So, for example, there is a hook to intercept all of the DDL commands or all of the queries when they are planned, or to intercept writes and do something different than what Postgres normally does. Very often you check, is this a query I care about? If not, I give it back to Postgres. But if it is a query you care about as an extension, you could do something else. For example, we could let DuckDB handle a part of a query, or we can handle DDL commands in a particular way, or writes in a particular way. And that way we can build this notion of an analytics table into Postgres, where you still have your original regular Postgres heap tables, but now you also have an analytics optimized table, which uses vectorized execution when you query it. Now, how do we actually store such a table? There are actually a few different options. One is we put it, we implement columnar storage in Postgres, and we store it in the Postgres buffer manager and write-ahead log. We've actually done this in the past with Citus columnar, and it works reasonably well. The problem is, again, that the Postgres buffer manager is not really optimized for analytical use cases. It's used these tiny 8 kilobyte pages and some locking on the pages. And then also it's not really thread safe. So we cannot have DuckDB, which is this multi-threaded query engine, use the buffer manager to its full extent. So another alternative would be, can we use DuckDB's native file format? So we just put a file next to the Postgres directory, and then those tables are just stored in the DuckDB file. The problem is that Postgres often has replication, and so only the things that go into the Postgres write-ahead log are going to show up in a secondary node. So if we fail over to a secondary, the DuckDB file is just not going to be there at all. Another option is we put the data into a separate storage, such as blob storage, object storage. And we could also have a cache on the server itself, so we can have some higher bandwidth, lower access latency. And then both the primary and secondary can talk to the same blob storage. And we can also keep some metadata in Postgres itself to remember which files are currently part of the analytics table. And we can use the Parquet file format in object storage, which is a very popular format for storing data in a columnar fashion. It's basically like CSV, but columnar and with well-defined column names and types. So as it turns out, there already is a table format that you can store in blob storage called Apache Iceberg. So Iceberg is a specification that describes a metadata layer. And the metadata files that also live in blob storage, they describe which Parquet files are currently part of the table, what's the schema of the table, what's the history of the table, what's the partitioning of the table. And then there's one top-level file, a JSON file, actually, that describes, this is really the current state of affairs. This is the current table. And as you write to this table, you generate new Parquet files, you generate new metadata files, and you generate a new top-level metadata file. And so if you want to query the latest version of the table, you need to know what the latest metadata file is. And that URL of that file is typically stored in what's called a catalog, but the catalog is basically a database. In fact, it can just be Postgres. So in our case, if we can create an iceberg table format in Postgres, we can also act as the catalog. So we can just do our bookkeeping in local Postgres tables. And we can have a very nice kind of transactional iceberg table format. And we can use the extension APIs to intercept writes such that we generate Parquet files and metadata files. And when the table is queried, we can use the hooks to let DuckDB handle part of the query, which makes it very fast. So we built an implementation of this idea called Crunchy Data Warehouse, which is basically Postgres with additional extensions to implement Iceberg and to also implement these data lake tables that can query CSV and JSON. And we often find this is actually 10 to 100 times faster than just Postgres tables on the same server for analytical queries because of DuckDB, but also because we use caching very aggressively. One of the nice things about Iceberg is that all the files are immutable, so you can cache everything. And we kind of moved away from the model. So we still use extensions exclusively, but we moved away from the one big complex extension model that we had in Citus because, well, one of the things that has happened in the extension ecosystem is there's now Rust extensions. So if we have a constellation of modular extensions, we can have some of them in C, some of them in Rust. We can also say some of these are open source, like PG Parquet. Some of these are closed. And it also just helps us organize our code. So we quite like that model. So with these extensions, one of the things we're adding into Postgres is this notion of an iceberg table. So you can just say create table using Iceberg, use most of the Postgres features like sequences, generated columns, triggers, constraints, just not indexes and foreign keys. And when you create a table, we'll write the metadata files, and then you can insert. If you insert a few million rows, it usually just takes a few seconds. But if you insert one row, it probably also takes a second because it does need to write a bunch of files into blob storage. So it's always good to batch things. But you can, for example, collect writes in a regular Postgres table and then move the data into an Iceberg table. Now, when you update an Iceberg table, so we'll use DuckDB underneath to scan the Parquet files of the Iceberg tables. And we'll ask it to give us the file names and the row numbers that match the filter in the query. And Iceberg has this notion of a position delete file, which defines which rows from the existing table get deleted. And those are basically pairs of file names and row numbers. So we can feed that information directly into a deletion file, and then the new rows go into a new Parquet file. We'll write the metadata files and update the catalog. And we can do a bunch of these updates in a single transactions across different tables, rollback, sub-transactions, everything. And then when the table is queried, we'll again use DuckDB to do a read Parquet. So this is just a function that DuckDB has to scan Parquet files. And then we'll filter out all of the rows that appear in these deletion files. So over time, you build up some table bloat, just like in Postgres, like rows have been deleted and we're filtering those out when we query. But every 10 minutes, we run this automatic compaction process where we take small Parquet files or Parquet files that are heavily deleted and we compact them together into new Parquet files. So this just happens every 10 minutes. So the way the querying works is, Postgres allows us to intercept the query planning process at multiple different stages and suggest alternative plans or kind of force it to use our plan. And so what we can do, the planner kind of goes, I see it as inside out, like from the from clause with the table scans, it goes outwards to the group bys and the order bys. So we start looking at a scan, which is like we're scanning this table, this Iceberg table with some filters and some projections, and we check, can this SQL, can we from the scan generate SQL that DuckDB can handle? If not, then we'll look at what it can handle and generate SQL for that. If it can handle everything, we move on to the next stage and check, can it handle the group by and the aggregates? If so, we'll move on to the order bys and the limits. And that way we kind of find the biggest possible piece of the query that it can handle. And for that, and we'll put that as a separate execution node in the overall Postgres query plan. So our query plan is actually a hybrid between stuff that Postgres executes and stuff that DuckDB executes. And sometimes there can actually be multiple DuckDB executions in a single Postgres query plan. And this way we can actually support any SQL query and also make it as fast as possible. So this uses this hybrid architecture where the Postgres processes, like if you store data in a Postgres table, it still uses block storage like Premium SSD, but then DuckDB, it stores the Parquet files in object storage behind this cache on a local NVMe drive. And so there's multiple Postgres processes talking to one DuckDB process, so that we don't have this super high memory usage if we put DuckDB in every process. So altogether, like running ClickBench, which is a popular kind of single table analytics benchmark on a Postgres table and also on an Iceberg table just on the same machine, like the Iceberg tables go up to like 50, 60 times faster, especially with the caching. But even without the caching, we fetch just the pieces of the Parquet files that we need. That's one nice property of Parquet files, that you don't always have to download them fully. Also TPCH with more complex joins. This benchmark we ran 14 times faster with Iceberg. And we really tweaked the hell out of Postgres here, adding all the indexes. Also, we used quite small scale factor. The difference is actually much bigger at bigger scale factors. So there's different ways in which we see people kind of using these capabilities. One of the ones that's been getting more and more popular is the sort of zero ETL log management. So, teams often have a lot of different types of logs in blob storage and want to do some queries on those. And there's a lot of tools that give you a type of SQL to run on your logs. But if we could get the data into an Iceberg table, then you can just use Postgres queries to query your logs. So one of the things we can do now is we create a table that points to our logs. The logs might be in CSV or JSON format. We also support some more kind of text formats that need to be parsed. And so you can create a table that points directly to those files. You could already query them at that point, but because of the JSON parsing, it might not be very fast. But what we can do is create an Iceberg table. It could have the same schema, or we kind of select more specific fields from that we're interested in and extract those from the JSON. And then we have this open source extension called PG Incremental, which basically I previously created an extension called PG Cron, and PG Incremental is essentially a layer on top. So it periodically runs a command, but every time it runs it with a different parameter value. And that value kind of goes through some sequence of things. So like after an hour, process the last hour, or process a range of sequence values. But you can also process new files showing up in blob storage. So when you run this command, it'll run this insert into logs Iceberg for all of the files that are already there in batches. And then whenever new files show up, it will run the command as well with those files as the parameter. And that way, and that's every time we run this is a transaction. So if something fails, we'll just retry those files. If it succeeds, we'll never try them again. And so basically in 3 commands, you set up this whole log pipeline and can now query your logs using Postgres, which is pretty nice. But this is if the data source is already files in blob storage. So what if your data source is actually another Postgres server? Like you have data in your operational Postgres server and you want to run analytics on that. So a few weeks ago, we actually released logical replication from Postgres to Iceberg. Again, using purely extensions, though it was pretty hard, but you can now actually go into any Postgres server and create a publication. And then you can create a subscription in a warehouse server where you use Iceberg tables as the target. You can also ask it to automatically create all the Iceberg tables, which will set up all the metadata files. And then the data starts automatically copying in the background. And once that's done, it starts replicating the inserts and the updates, deletes, and truncate commands. It does micro batches, so it accumulates some of the changes in Postgres, and then it flushes those into Iceberg to generate the new Parquet and metadata files. That still generates some small files, so then every 10 minutes, those files are automatically compacted as usual. So I have a little demo of that setup that I'm gonna switch to now. So here I'm connecting to my production database, my operational database. It has a table with about 1 billion rows. I mean, synthetic data, but and let's say I wanted to do an analytical query, simple analytical query, and it takes 4 minutes, and it probably puts an awful lot of load on my database. So I don't want that. So what I can do now is create a publication with all my tables, connect to the warehouse, and then create a subscription with the connection string and the publication name. This goes and creates the Iceberg tables, and the data starts copying in the background. It takes a while. It's 1 billion rows, so we're kind of fast forwarding in the video. But now I can run that same analytical query, and it finishes in 300 milliseconds. That's a bit idealized because I haven't had any updates yet. So let's run some updates using pgbench. So these are transactions that do 1 insert and 3 updates, I think, per statement. So 10,000 writes per second total. And then on the right, you kind of see what happens with the Iceberg tables. Like they sort of sit at the same version for a while, and then they jump forward because the changes have been applied. So that way we can kind of directly replicate from any Postgres server into these analytics optimized Iceberg tables. And so in summary, you can turn Postgres into a data warehouse, into a modern data warehouse or lakehouse, as some people like to call it, with support for Iceberg, which has become the sort of the main table format in analytics systems, and also full transactions across Iceberg tables, across Postgres and Iceberg tables. We can make it very fast by integrating DuckDB and this write-through caching. I mean, it'll never be faster than DuckDB, but because you typically run this in the cloud and you have this extra cache, it pretty much goes as fast as possible. Then if you need to scale out, you can also point tools like Spark and Trino directly at the Postgres server and use it as an Iceberg catalog, and then Spark and Trino will pull the data directly from blob storage. And I mean, there's a few different teams kind of pursuing this architecture. We were a bit early, so like we shipped the first production ready version last November. So let's see how it goes. It's a very exciting new motion in the Postgres space to add these analytical database engines directly into Postgres. So if you have any questions, feel free to ping me on Discord or send me an email or look me up on LinkedIn. We also write a lot about our projects and general Postgres tips and tricks on our blog. So also recommend going there. Thank you very much. Great to be part of another Posette.
Wow.
Thank you, Marco. Well, that's a great talk. I always like seeing what Marco is up to. It's always very interesting. And I know that Marco is actually chilling in the Discord hallway track, so drop by and throw some questions at him. That I see there's already some discussion about Duck Lake, so you might want to go and read that. And while you do that, please do the survey. I'm sure Marco would like to know how you like this talk, some feedback. There was also a topic just recently in the hallway track on how important the feedback is for speakers to improve. And if you like to listen about PostgreSQL, actually something that was born between these conference instances was a podcast that Claire Giordano runs, which is Talking Postgres. Claire is also in the Discord hallway track, so we can ask her more about it. Like maybe she will reveal what's coming up next. So drop by, do a listen. I love listening to this as I'm driving in the car. It's just a great way to pass the time. Next up, we have Derk van Veen. Derk works for Adyen, and Adyen is running PostgreSQL. His talk says at a large scale. I would say like at a ridiculously large scale. And he will be talking about partitioning for query performance and getting up to 50 times performance improvement. So I'm really looking forward to this talk and seeing what Derk has for us.
Hi, my name is Derk van Veen. I'm a database specialist at Adyen, and I mainly work on a partitioning framework. So, of course, this talk is about partitioning. So if you're managing tables around 100 gigabytes and more, this is definitely the talk you want to see. All right, let's have some fun and dive in. Leveraging table partitioning for query performance and data archiving. Maybe I lied a bit about the title, but I forgot, or actually I didn't know about the moment I did the submission. So this is the title and this is what you have to do it with. And today I'm talking about partitioning. And I was surprised because I've been working on partitioning quite well now. And I was looking for examples around partitioning. And then I found the perfect example of partitioning. And actually, I didn't see this one coming, but the supermarkets are so good at partitioning. They do partitioning everywhere at many layers. And they also use it to stop people. Because when you enter the supermarket, there's the fruits department and the vegetables. And it's green and fresh, so everybody immediately slows down a bit. And then there's the first layer of partitioning, because there's fruits and there's vegetables. And then in my supermarket, when I continue, there are the cans. And within the cans, there's a lot of partitioning. Like the cans they want to sell the best, they are at eye level. But then at eye level, there's more partitioning, because the stuff they want to sell first is in the front, and the cans they want to sell later are in the back. So they're also using partitioning to manage the stock. And then I was trying to visualize a supermarket where all the products are basically scattered all around, and you just get a map, and it's like cans. There are some cans on the left, some cans in the middle, some cans on the right. If you want the beans, they are on the top. It would be chaotic, right? So I was thinking, like, what can we actually learn from supermarkets to store data more efficiently? How can we manage our data lifecycle management, like the stock? What is the data we want to give first, and what data can wait a bit? So that's what I'm talking about today. And I hope after this talk, you will be able to make your queries faster, do your data lifecycle management better, and have lots of fun with partitioning. So I would say there are 3 reasons to do partitioning. And the first one is also a really bad one. But Postgres has a physical table size limit, which is 32 terabytes. If you are hitting 32 terabyte table limit, you are way too late with partitioning. I will not say I've been there, but don't go there. The good reason to do partitioning is, I would say, make your maintenance easier. So if your tables are getting around 100 gigabytes and more, it becomes time to think about partitioning. Because vacuum a big table, especially heavily updated table, is getting more intense. And you don't want to wait too long before you start partitioning when your maintenance is already out of control and then you have to do all the work under pressure. So by the time, I would say 100 gigabytes, then maintenance becomes harder, and that's a good moment to start thinking about how do I want to partition my environment? It's not about partitioning a table, it's about partitioning your entire environment. That's an important concept to get. And then finally, if you are having 100 gigabytes of data, you know you will get more data. If you get to 100 gigabytes, you will get to 200, to 500, to many terabyte size tables. So, and when you get to this table size, it becomes time to think about when do I actually want to get rid of this data? So how do I get the data out of my system, and how can partitioning help me with that? These are the three main topics for today. But let's cover the basics first. I would say there are, again, three types of partitioning. First one, it's list partitioning. And list partitioning, I would say it doesn't really tick the boxes, because I can split my table in this case, in three pieces where I store Postgres, MySQL, and DB2 in separate partitions. But if my data was already growing a lot, these partitions will also grow a lot. All right, I may have slowed it down a bit, but it's still not sizable, I would say. So if you look at, is this long-term ease of maintenance? Not really. Is it helping me with with data lifecycle management? Also not really. So for me, list partitioning, maybe it's nice for some people if you want to do some reporting, but in general, I would say it's not the way to go. The second one is hash-based partitioning. And for some reason, developers love hash-based partitioning. So you have some random value, you do some magic, and then you have some remainder left. And based on the size of this remainder, you store your data in partition 1, 2, or 3. And this seems to be a nice way to split your data. And when you're under heavy insert load, the insert is spread over all the boxes. And that's kind of a nice thing. But then think about what happens if I want to double the amount of partitions. Then suddenly the remainders are all different. So there's no other way for me to redistribute all my data over all new partitions. What if I have collected 100 terabyte of data over these partitions, and now I want to redistribute this data over the new number of partitions? The impact on the system would be huge. So it seems to be scaling well, but it actually doesn't scale well. And there's a second thing I don't like about hash-based partitioning, because a hash is a random thing. And if you're inserting into an index at all kind of random places, you are inducing a lot of full page writes for these index pages, and that's just hard. So again, hash-based partitioning seems nice, but for me, doesn't tick the boxes. It's not the way to go. So, well, this is only the third option out of 3, so this must be the box I need, right? Does it help me to get an infinite number of partitions? Yes, it does, because it's a range. It goes from 0 to a billion, or it goes from January 1st to January 31st. And I can always create new partitions in my range. And within Postgres, before you get to the theoretical limit of the number of partitions, you are very well on your way. And also, does it help me with data lifecycle management? Yes, definitely, because all the data is nicely together within the partition. So this partition is always older than this partition, which is really nice. So I would say the most natural way is to partition by dates. A date fits a nice time frame. We humans are good at this. So in this case, I have partitioned from January 1st to February 1st. The lower boundary is always included. The upper boundary is always excluded. And this works really well for example, PII data, where you can not keep your data around for over 5, 7, or 10 years, depending on where you collected this data. So if you want to get rid of files after 5 years, this is a really easy way to do it. So let's see how this works. Let's say I created a table with 3 partitions, and all of these partitions are empty at the moment. But of course, this is how life goes. At some moment, data will be inserted in my partition. Now I have only 2 partitions left, which are not in use, and I don't like it. So what I do is I will create a new partition, because I always want to have some partitions in reserve. So if I'm not creating new partitions for some reason, I always give myself some slack. I always have reserve space for incoming data. And then this space basically fills up, right? I get more and more data coming in, my partitions are filling up, and at the bottom I have my empty partitions. And at some moment in time, I have some nice window, and this is all the data I want to keep. But the data which is older than this window, I no longer need. And of course, you can write a cleanup job, and this can go through all of your data and then delete it. And then hopefully your cleanup job is as sufficient as the data which is coming in, so you can actually keep up with all the incoming data. But it's actually way easier to say like, hey, my upper boundary of this partition, it's older than, in this example, 10 days. So these are probably log files. I don't want to keep my log files forever. So if my log file is older than 10 days, the upper boundary of my partition is older than 10 days, I know I don't need this information anymore. So I just detach this partition from my parent table. I on purpose say detach the partition from my parent table because I don't want to delete it immediately. I'm the one who created this function, who's doing the work, and I know I make a lot of mistakes. So I rather detach it first and then have some cooldown period before I actually delete data. Because reattaching a partition is really easy. Restoring the partition from a backup is a lot of work, and that's something I don't like. And I created a solution for date ranges, and it's worked like a charm. And I was really pleased with myself, even though it was a very simple thing to do. And I was like, I will do the same thing for integer partitioning. And I was like, do I really have to do this? It's kind of boring. I will manage. But let's pretend these are integer partitions. I was like, all right, I can look at the total number of partitions, and if I have 9, I can get rid of the 10th. But then I was thinking like, what happens if the range of a partition becomes half of the range because of whatever reason we change the size of the partition? Then if I would rely on the number of partitions, I would suddenly throw away data I would still need. So this was kind of a tricky option, and I didn't like it. Then I was like, well, maybe my partition has a nice date column, and I can look at this date, but then not all tables have a date column I can use. So that's also an option I don't really like. Well, and then I try to look at the number of active partitions. And then for me, an active partition is a partition which actually holds data. And then I was like, yeah, but what if there's an error in either my calculation or in an application, and we suddenly insert data which is already in the future? Then suddenly I would drop way quicker partitions from the past. So again, this option was kind of tricky. And then I was left with, yeah, maybe I can do this based on the creation date. But again, what does the creation date even mean? And maybe I do some maintenance, I do some trickery, I swap partitions. So creation date is also not good enough. And I was like, well, I can just create a metadata table. But then what do I actually put in the metadata table? Because I already discarded all the options I had. So it turned out not to be so easy. And then I came up with a new plan. I can run a query against every partition I have. And if this query has to return a date. And if this date is older than the window I specified, that for me is the sign I can actually detach this partition. So how would that look like? Someone just provides me a query, someone who actually knows more about the data than I do. And I just run this query against all of my partitions. And this is the way how I can decide I can get rid of this partition or I need to keep it around for a while. And I would say this is a very fail-safe option. So finally, I'm now able to do lifecycle management based on an integer. The next important thing, joining tables. Maybe this is no, not maybe, this is definitely the most important thing if you're working with partition tables. Because we are working with a relational database, right? And most tables have a primary key, which is some kind of a technical key, probably an integer. And we want to join based on this integer because if you partition, the primary key has to be part of the partitioning key. And I only want to do a single layer of partitioning. For me, that's already hard enough to manage. So I don't want to go to 2 layers of partitioning. So I only have a single partitioning column. And then joining becomes really important because this is why I said leveraging query performance with partitioning is important, but it's actually the other way around. If you mess up your partitioning, the query performance is dreadful. And I learned this the hard way. So I learned if I improve my partitioning, the query performance goes up, and it goes up like 50 times, which is a lot, but only because I screwed it up in the first place. So how does partitioning and joining work? I have a trivial example, table A and table B, and they have a primary column, which is C1, that's the column 1. And I have some trivial query, select all the columns from table A, join table B on the primary key, where a value in the primary key is 500. Well, the optimizer knows this is in the first partition for both tables. So it will nicely go to table A, first partition, table B, first partition, join it. Everybody lives happily ever after. But then when queries become even slightly more complicated, something goes wrong. So I changed my where clause to where C1 is in 2 values. So now I expect the optimizer to use partition 1 and partition 2 for table A and partition 1 and table 2 for table B, because that's where the data lives that I'm asking for. But because of this where clause, it's nicely applied to table 1. That's something the optimizer can do. But then it scans all 3 partitions for table B because it doesn't have a clue how the partitions match. And in this case, I have only 2 and 3 partitions. But in a real life environment, this might be 2 partitions and then 50 partitions. And if I join with table C, that's another 50 partitions. So instead of reading data from 6 partitions, I would be scanning indexes on 2 plus 50 plus 50 is 102 partitions. That's a lot of work, and that's how you get poor performance. So you have to align your partitions around the leading figure. What does this mean? These are some great leaders from the past, and I can tell you at the moment we have a prime minister in the Netherlands, and he's not related to any political party. And he's leading a government which consists of 4 political parties, but the leaders of the political parties are not part of the government. So on one hand, we have 4 leaders making fuss on social media, and on the other hand, we have a partyless prime minister who's trying to make an omelette out of 4 eggs without breaking either of the eggs. I can tell you that's a mess. So what does a leading figure mean when it comes to partitioning? I would say a leading figure is the figure that holds your data together. So within Adyen, we do a lot of payments. So it can be a payment identifier, because my payment identifier is what's keeping everything together. Everything is related to a payment. If you're working for a bank, this can be a bank account ID or a bank ID or a person. I worked in insurance companies, and then maybe the leading figure would have been a insurance object or a insurance policy. So if you're working with cars, maybe the car is your leading figure and all the parts are circling around the main car. You need something that really ties all your tables together. And maybe that means you need to denormalize your data. Well, so be it. It's a lot of work. It's a lot of hassle, but you have to go through it if you are partitioning your environment, because you will need the same partitioning key on all of your tables. But then pay attention, this is what you get. So you remember this query with the complicated where clause. because now I partitioned my tables on the same column and all my partitions are aligned. So the bottom value and the upper value are all the same for all of my partitions. And then it still doesn't work. Well, why doesn't it work? Well, there's one more trick we need to do. We have to enable partition-wise join. This is using a bit more CPU cycles when it comes to query planning. And we are always afraid to mess up people's environments for no good reason. So if you want to do more efficient joining with partition tables, you have to turn the setting to on. And now if you run this query, you are only looking at the partitions you actually need. And this is a huge win. And to get a huge win, yes, you might need to do a lot of work. Maybe you have to include a new primary key into all of your tables, but 50 times faster queries, that's definitely worth it. And then I want to show you this because I think it's really cool. I have a new favorite data type, and I thought I was the only one not knowing about this, but apparently I'm not. It's the UUID v7. I will go through it very quickly. I was confused at first. There was this developer, Rick, he was coming to me and he said like, I want to do partitioning on the UUID v7. And I was like, no, Rick, you're a really smart guy. You know what you're talking about, but this is a really bad plan. So what is a UUID? Well, basically it's a very long hash, but the first part of the hash is a timestamp. So the first 48 bits are the timestamp up to milliseconds. And then the final 72 bits are basically random. So within every millisecond, you have 72 bits of randomness to make the value unique. So that's a lot of randomness. And you can do some really cool trick when it comes to partitioning with UUID v7s. So let's say my primary key is now a UUID v7, but that's two things. First of all, it's unique. And second, it has a date in it. So now I can combine the benefits from date partitioning and integer partitioning into a single value. So this is how my partition boundary would look like. This is basically a date. It's just randomness. So my partition starts at January 1st, 2025. Then if you did your calculation well, a UUID v7 is 128 bits, 38 bits for the timestamp and 72 bits of randomness. That leaves 8 bits for information about the UUID. That's the number 7 and 8 you see here. And for partition boundaries, I set all the randomness to 0, so I have nice, clean boundaries. And now I can set the upper boundary for this partition as well. And again, this is basically a date, and I do this for all my other partitions as well. But think about this. UUID v7 boundaries are basically just dates. And now they are both dates, so life cycle management is really easy, but they're also unique, so I can use this value for joining as well. So if you're about to start with partitioning and you can implement UUID v7s as a partitioning key, that's definitely the way to go. Then, finally, data lifecycle management. I think this is so cool. I'm so proud of this solution. We don't have it live yet, but we are working on it. And I just want to share it because it's so cool. You remember this picture, right? After 10 days, 5 years, 7 years, you want to get rid of your data. But actually, after I want to have this data in my primary system anymore, to be honest, because the payment is something which is living very briefly, right? It's after a year, nobody wants to refund the hamburger they bought a year ago. So nobody looks at the data anymore. So I want to get rid of this data after a year. But the application might still need this data for reporting. So what I want to do is a trick. So I have some huge archive because our primary system is living on some really fancy flash disk really fast. But I have this data nobody cares about. I can move this data to a way slower system, which is way less expensive, and it's not burdening my primary system with all the maintenance load to keep this old data around. I want my primary system to be small and flexible and really fast and easy to manage. So what I can do now in this archive database, I create a table, a partition, with the same boundaries as I had for my main partition. And I copy the data from my primary system to this archive system. And what I now can do is a trick. Of course, this copying takes time, but I don't care whether it takes a lot of time or not. I want it to be completed in time, which if this is a month of data, I have basically a month minus 1 hour to copy it, but it needs to be accurate. And then I can very briefly lock the table on the primary side, and I can make a switch here. I will create a foreign data wrapper, which goes from my primary to my archiving system. So this is completely transparent to the application, but my primary system becomes way more smaller and easy to manage. And this is just really cool. And nobody knows about it. The devs don't know about this. It's just something I can do in the background. And for me, that makes this really a lot of fun. So already time to talk about the summary. I don't have more time to talk about it. So the lessons from today, what do you really need to take home? I would say there's only one good way to do partitioning, and that's range-based partitioning. That's the only way you can scale forever. Data lifecycle management is easy, and it really helps to get maintenance easy on the long run. And if you have a choice, definitely go for the UUID v7 because it combines the best of both the worlds for date range and integer range partitioning. You can't do partitioning table by table. You have to partition your entire environment. So you have to find your leading figure and you have to implement the leading figure in all of your tables. That's the only way to get good query performance. So spend the time, spend the effort, and get your leading figure in place. And then when you have your nice stack of partitions, you can actually decide, do I want to remove my oldest partition and get rid of all the data in one go? Or do I actually move it to some archiving system, transparent to the application, and keep this data around for as long as you need it for whatever reason you need to keep your data around for? But it's not burdening your primary system, and it's not burdening you're not hiding it from your application. So this is a really cool thing. If you are doing partitioning and you are on a lot of load on your system, I would say you can use the LTM partitioning framework. It's free, it's on GitHub. You can use it for all your partitioning work. And if this talk was a little bit too fast for you today, there are 4, I want to say blog, but blog doesn't really cover it. I think 4 very lengthy articles about how you can do partitioning, how to leverage partitioning, and basically it's a brain dump of everything I know about partitioning. So that's it for today, all the time I had. Thank you very much for listening and hope to see you around. Bye-bye.
Wow, thank you so much, Derek. That's a really great intuitive explanation of partitioning, and it looks like you have some really cool tools there. Yeah, go and check out Derek's deeper articles about that. Don't forget, everyone who's tuned in or watching later, to check out the survey, leveraging table partitioning for query performance and data archiving. You might get some socks. And it's time now for us to hear from Amit Langote, who is a colleague of mine. He's also actually known for his work on partitioning inside Postgres, some of the machinery that makes that work. But his talk today is about something else. If you caught Marco's talk about the divide between OLTP and OLAP systems and the way that query execution works differently in those systems, then you might recognize some connections also to Amit's talk today, which is about the executor architecture, the whole volcano thing, processing one tuple at a time, and what we might be able to do about that. So yeah, Amit, take it away.
Hello, I'm Amit Langote. I work at Microsoft in its Postgres open source team. In this talk, I'm going to talk to you about how Postgres Executor interacts with modern CPU and how that impacts its OLAP query performance. I'll talk about a few things we've done to improve that, and then some architectural directions we could take in the future. So if you're interested in OLAP performance, please join me. Okay, so let's get started. So the title of my talk is Hacking Postgres Executor for Performance. So again, I'm Amit Langote. So I've been working on Postgres for Postgres internals for over a decade at this point. In terms of how I started my community work with table partitioning that came in version 10, and I've been working on improving that over the many releases along with many others in the community. I'm now at Microsoft, and I've previously worked at EDB and NTT OSS Center in Tokyo. I'm from India, but I've been living in Japan, Tokyo, for over 12 years at this point. Okay, so here's the agenda. So we'll start by grounding the talk. Why focus on executor performance? What kinds of overheads actually matter, and how do they show up in real-world queries? So I'll talk about both OLTP and OLAP, but mainly OLAP. Then we'll look at how modern CPUs execute code, things like how they use caching and pipelining and branch prediction, followed by how Postgres Executor executes queries using the Volcano model, and why that model struggles when it comes to making good use of the CPU. Next, we'll cover improvements that are already committed, things like reducing function call overhead, improving tuple deformation, and making scans more efficient. Then we'll look at the changes that go beyond these local changes, things like adding batching to the executor, push-based execution instead of pull-based execution, etc. And yeah, if you have any questions, you can ask them on Discord. And if you have something more you want to ask, you can just shoot me an email. Okay, so like in transactional systems, queries are short, and often they just return a very few rows. In this case, executor startup costs, like initializing plan nodes and tuple slots, can dominate the total time. This shows up especially using prepared statements or extended query protocol, where you don't plan on every execution, but you have to initialize the plan, or you have to do the executor startup every time. On the other hand, analytical queries, they process millions of tuples, not just few. And each tuple has to go through the executors, things like doing tuple deforming, expression evaluation, and plan node dispatch, etc. And if that machinery doing all those things is not efficient, then these overheads can add up pretty quickly. And if you reduce those overheads, they can also show up significantly. So to summarize, OLTP, we care about improving the executor startup performance. And for OLAP, working on per tuple throughput can make a whole lot of difference. And we can talk about both, but in this particular talk, I want to focus on things that help the OLAP situation. Okay, so let's start with some theory. First, on how modern CPUs actually work at the low level, and then we'll look at how Postgres execution model fits into that picture. Okay, so modern CPUs, they rely on multi-level cache hierarchy, kind of to hide the memory latency. So we have L1 cache that's extremely fast. It takes about 1 nanosecond to load from L1 cache. L2 and L3 are slower, but they are still faster than the RAM, which takes on scale of hundreds of nanoseconds to do a load. And to stay fast, CPUs depends on cache hits. So when data is already in cache, execution can just proceed smoothly. But when it's not, CPU has to fetch data from like slower memory, whichever it may be. So if it's not in L1, it has to look into L2. If it's not there, then L3, and then right. All this takes time. The second point is sequential memory access is more cache friendly because CPU can load one cache line and can reuse it efficiently across nearby accesses. On the other hand, if you have scattered access, then CPUs will run into many cache misses, and that can affect how it works on the program. So here I'm showing how if your program is accessing memory sequentially, it can CPU can just fetch data into its L1 cache, and if you access, for example, an array, if you access it sequentially, then there's a guarantee that subsequent accesses will be served from the cache. On the other hand, if your program is accessing an array all over the place, then every access is going to run into a cache miss and result in a slow RAM access. So modern CPUs don't run one instruction at a time. They use pipelining, and what I mean by pipelining is that each instruction goes through stages, like you have fetch, decode, execute, and write back. So these are kind of roughly the 4 main stages. Of course, they are broken down into like smaller like micro stages, but I'm just going to mention these. So what this allows CPU to do is it lets it process multiple instructions at once. So one per stage and per cycle, as long as nothing stalls. But when an instruction can't proceed, like after a cache miss or a mispredicted branch, the pipeline has to stall. So in the diagrams that I'm showing here, in the left side, you have instructions just proceeding without getting blocked. But on the right hand side, I'm showing in cycle C3, when instruction I1 is executed, it runs into a cache miss. And what happens in the next couple of cycles is it has to wait for that cache miss to be resolved by fetching the data from RAM or whatever. And what happens is C4 and C5, nothing useful is really happening. I mean, I'm simplifying things here a bit. It's only that anything that depends on I1 has to kind of line up behind I1 getting unblocked. But in reality, CPUs can run anything that doesn't depend on I1 being finished. So, but I'm simplifying things here. If everything depends on I1, you are going to see a actual stall. All right. Another thing is modern CPUs don't wait to see how a branch resolves. It speculates. So CPUs will guess what path will be taken and begin executing instructions ahead of time. So what this does is it keeps the pipeline full and it avoids idle cycles. So if the guess is correct, all the speculative work gets committed as if the CPU had waited. So there's no time lost. But if the guess gets wrong, then the CPU has to backtrack. So it has to flush the pipeline. It has to discard the result of the speculative work that was done, and it has to restart from the correct branch path. That means that clearing the reorder buffer and refetching instructions, and it usually takes many tens of cycles. So branch mispredictions are one of the core causes of pipeline stalls. So when the CPU guesses wrong, it has to flush and restart, just like we saw earlier. So what are the main reasons for these? So one of the main reasons is data dependent branches. So here I'm showing a condition. So if the data for threshold in this condition varies a lot, then the outcome becomes hard to predict for the CPU, and mispredictions will rise. So and the second reason is indirect branches. So things like if your program uses function pointers a lot, then the CPU has trouble, predicting the target address. If the program is using, there are direct jumps and indirect jumps. If direct jumps are hard to predict, easy to predict for the CPU, but anything that depends on the jump address, if it has to be calculated, then CPU has trouble like predicting those target addresses. Okay, to summarize, all these techniques that we've covered, things like pipelining, speculation, caching, etc. All of those techniques rely on CPU seeing predictable control flow and memory access. If you have branch-heavy code and unpredictable memory access patterns, then those things break that model, and the CPU spend time stalling and recovering instead of doing any actual work. If you're curious to go deeper into how CPUs actually behave, I recommend watching this talk by Matt Godbold. It's named What Every Programmer Should Know About CPUs. I think it's a good overview and it's well worth watching. Okay, next, let's take a look at Postgres execution model. So Postgres uses the classic volcano model. So the query plan is structured as a tree of operations. So scans at the bottom, joins, filters, and aggregations higher up, and execution flows top down. So if a node needs a tuple, it will call next on its child. So for example, here, aggregate will call next on join, and it will call next on its child two children, which are like base scans. And then the scans will actually read from the whatever table access or index access method that we have. So once a tuple is produced by the scans, it bubbles up back of the tree. So what's good about this model is it's very simple and it's modular. But as we'll see next, what it's not good at is using CPU efficiently. So in the volcano model, each tuple triggers a cascade of function calls. So each node will call next on its children or child. So producing one tuple often means many function calls throughout the tree. What this does, it adds overhead, and it makes it hard for the CPU to predict control flow efficiently. And memory access is also scattered. So you have to move between nodes and buffers and tuple table slots, which hurts cache locality, and it increases stalls. And each node typically has many condition checks, things like qual and projection and things like that, which adds more branches for the CPU to predict and, well, mispredict. And when these predictions go wrong, you get pipeline stalls and wasted cycles. Okay, so why can't compiler help optimize this code? Postgres query plans are built at runtime. What I mean by that is ahead of time compilation, meaning when you are building the package, you can't optimize for specific queries or plans. Of course, that's pretty obvious. So that raises the question, can we still benefit from compilation at all? In some localized parts of the executor, yes. So we've used inlining, for example, to specialize deforming logic and scan code paths, as we'll talk about in a bit. But broader executor optimizations are much harder to optimize at compilation stage. So execution has to flow through function pointers like exec proc node, etc., which prevents inlining across plan nodes, and it hurts many conditions will hurt branch prediction. The tuple access is also runtime dependent, so you have to check null flags, and you have variable width attributes, etc., especially with robust storage that we have in Postgres, which makes memory loads irregular and unpredictable. So that limits what the CPU can do with prefetching and branch prediction, etc. We do have JIT, just-in-time compilation, but it only works for expression evaluation. And it does help reduce the interpretation overhead for expressions, but JIT doesn't restructure executor's control flow, plan node dispatch, etc. So JIT currently doesn't help the overall executor as such. So the overall plan execution still remains dynamic. So to improve the executor performance at broader level, we'll have to look at some architectural rewrites that we'll take a look at towards the end. Okay, so now that we've seen how the executor interacts with CPU performance, let's now look at what's already been done to make things better. So in this section, we'll walk through some optimizations that we've committed over the releases, things like reducing function call overhead, improving cache locality, and reducing unnecessary branching, etc. And each one addresses very specific bottleneck in the execution model, but they were good improvements. Okay, so first let's look at expression evaluation. So Postgres used to evaluate expressions by walking the expression tree at runtime. Each node, like a constant or operator or a function, was processed via its own function call, which this meant that you would have deep call chains and many small functions, which hurts instruction cache locality, and it made it hard for the CPU to predict control flow. This was rewritten to use a flat opcode-based execution model. Instead of walking a tree, the executor runs a tight loop over opcodes, which is much better for the CPU. You have fewer branches and you have better cache usage, both data and instruction, and easier target prediction. With this change, expression evaluation in TPC-H, for example, was improved significantly, like by many tens of, like up to 30% improvement, even more in some cases. Next, reducing function exec proc node overhead. So originally, all plan nodes were executed by calling exec proc node, which looked at the node type and then dispatched to the right function for the plan node. This meant that you would have an extra function call for every tuple plus an indirect jump based on the node type, which hurts branch prediction, and it adds overhead, of course. So now, after this rewrite, each node stores a direct function pointer. For example, for sequential scan, its plan state node would store a function pointer of exec sequential scan, which is the execution function for a sequential scan. What this does, it avoids the centralized dispatch, and it also eliminates the per tuple overhead of calling exec proc node in the first place. Yeah, and it also reduces CPU stalls because of branch mispredictions. Branch misprediction to predict the which node function, for example, would have to be called. And this also improved performance, even if it was a minor improvement, but coupled with some other improvements, this was a good improvement. Next, heap get page. So heap, we have heap access method. So this is not really executor code, but for sequential scans, improving heap fetch performance matters a lot. So before this change, every tuple fetched from heap page was checked for visibility and serializability. So even if those conditions didn't change for the whole page, the previous code would check these conditions for each tuple separately. So what this meant inside this loop on the page is that you have like repetitive branching, which CPU couldn't predict well. And the new approach, what we've done here is the loop of reading tuples from page was kind of extracted into a new separate inlineable function called page collect tuples. What it does, and it accepts these flags for check visibility and check serializability as flags. So the caller can just check if a page needs visibility check or serializability check once for each page, and just pass the value of that flag to this function. And what the compiler does is it specializes that function based on the conditions, based on the value of these flags. So in each specialized variant of this function, you have fewer condition checks and fewer unpredictable branches. And this makes sequential scans run significantly faster, especially for all visible pages, especially if you do vacuum properly. Next, let's look at tuple deforming. These are the things we've done in version 18. Tuple deforming used to access information for each column by fetching the whole PG attribute struct, which is about 104 bytes per attribute. What that meant is you have to touch many cache lines for every column, which is especially bad for like wide tables with many columns. So this was replaced with compact attribute struct, which is a much smaller struct, which it kind of compresses the necessary information down to just 16 bytes. Those 16 bytes contain all the information that's needed for actual deforming. So now the deforming logic has to load fewer cache lines, and which improves cache locality and also reduces stalls due to mispredictions. Next, in tuple deforming, so previously we used to use this function called at align nominal for each column to compute alignment for loading that column's value into memory. So this involved checking type alignment, whether it should be 4-byte or 8-byte, etc. And it involved conditional logic. So these branches were hard to predict, especially for wide tables with mixed types, which led to frequent branch mispredictions in tight loops. Now we store required alignment value in the compact attribute struct that I mentioned in the previous slide. And it uses this micro type align, which has no branching, which is just a mask and add operation. This results in a branchless, faster deforming loop, which combined with having a smaller compact attribute struct improved performance significantly. And finally, in tuple deforming, there was one loop that handled all the cases. So you would have one loop would check for each column, would do a null check, variable length check, and alignment logic check. So there was no specialization. Each loop would check all these conditions for every column. Now we have a fast path that calls the inline helper function with pre-computed values for whether to check for nulls or not. So if you have this information in the tuple header, so you check if the tuple has nulls. If not, then it would just pass false for has nulls. And this function slot deform heap tuple internal will be specialized by the compiler because it's inline. Compiler can specialize it for different values of these, whether to use slow path or whether to check for nulls, etc. And so typically you would go through like fast path for the first few columns, for example. And once you hit like a null for the first time or a variable length attribute for the first time, then you enter the slow path. So if you have tables where you optimize like type ordering, the new code can use fast paths. You can separate between fast path behavior and slow path behavior, which improves performance significantly. So together, these tuple deforming changes makes tuple deforming more CPU efficient because as we saw, we have reduced cache misses because we use smaller struct to store tuple deforming info. And also by reducing conditional logic, we reduce branch mispredictions. So my colleague David Rowley did some many benchmarks, and he observed improvements of up to 25% in best case. And yeah, the improvement was pretty significant. Okay, finally, we also refactored exec_scan to use inlining. So previously, exec_scan handled all scan logic, so it would have check for checking is eval plan qual, the thing that's used for read committed isolation level is necessary, and whether we have quals or projections, etc. All of these things were checked like in one function, one general purpose function, and all these things would be checked for every tuple that would go through that function. So even when these features are not used, we would pay the cost of checking them for each tuple. Of course, that leads to mispredicted branches and instruction cache load because you have this big function. So the fix was to refactor the core logic into exec_scan extended, which takes flags for EPQ, qual, and projection. And because these conditions are known during plan initialization, based on looking at the plan node, we can the compiler can look at these condition values, and it can specialize away the condition checks by generating fast branchless code for each set of conditions. So for example, for sequential scan, you'd have these different combinations and these different variants that are passed different values for these different features that need to be checked. So by inlining scan logic and eliminating unnecessary per tuple branching, we make better use of CPU's instruction cache and reduce pipeline stalls. And these things add up. For a sequential scan, if you're scanning many millions of rows, these things add up. So the improvements, I benchmarked this, and in the best case, we saw up to 10% improvement of sequential scans, but on average, we could see up to 5% improvement. Okay, so now let's look at where we can go next. So what kind of bigger architectural changes we can make to the Executor. So things like adding batching, using push-based execution instead of pull-based, and using vectorization, things like that. Okay, so first, opcode-based or push-based execution. The traditional Volcano model walks the plan tree by calling exec prop node recursively. So each node pulls one tuple at a time from its child. So in an opcode-based model, we flatten this control flow into a tight loop over compact operations. Each opcode represents an action, think like fetch from access method, filter, project, or whatever. And we execute these operations in sequence. What this does, it avoids recursive function calls and deep call stacks. It improves branch prediction, and it makes the instruction stream more cache-friendly. It also opens the door to more efficient JIT execution, for example. Since the control flow is explicit and compact, it typically becomes like a one function instead of one function calling other function and so on. So this direction was outlined in 2018 by Andres Freund, my colleague, and much of what I also described in the previous slides, kind of came from that thread. Okay, batch processing and vectorized execution. So in the current Volcano model, every tuple requires a call to next, which means that a function call for every tuple, plus any branching and dispatch that comes with that. So what batching does, it amortizes that cost by processing many tuples per call. Typically some power of 2, like you might process 64 or 128 or even more tuples per call. What this does, it reduces the number of function calls and improves CPU utilizations for reasons we discussed. It also creates a more predictable execution flow, and of course reduces branch mispredictions, etc. And if the storage is columnar or has a SIMD, single instruction multiple data friendly layout, batching also enables vectorized operations, so operating on entire column or like tuple groups at once. So this model fits better how the CPU wants to execute. So what I mean by that is it wants full pipelines and fewer unpredictable jumps. Finally, compiled execution. So today we use JIT to speed up expression evaluation, but the rest of the executor still runs as a dispatcher. In a fully JIT compiled executor path, we generate optimized machine code for the full query plan, not just these expression trees. So that means that there is no per-tuple calls to exec proc node or branching to find the right node logic, etc. So control flow gets flattened into like one function as such. So everything becomes one single fight loop. All of this eliminates like function pointer dispatch and branch loose predictions. So you are basically removing interpretation from plan execution. So what it allows the CPU to do is it can see and optimize the whole instruction stream across the plan, not just parts, the expression parts. Of course, the trade-off is compile time. So this makes the most sense for long running queries where startup cost is amortized. Okay, so that's all I had. Thanks for watching.
Great talk. And for the questions, be sure to go to Discord. Ask them there. There are already multiple threads of discussion going on all day long, so don't miss out. But most importantly, do the survey. The survey is a way to get your chance in, getting a pair of socks. They may run out, so first in, first served. Do the survey. Do the talk survey. And with that, let's move on to our next speaker, MJ Peña, who is both a Microsoft MVP, but also a director at Playtime Solutions. MJ Peña will tell us about building RAG, which stands for Retrieval Augmented Generation, applications with Azure Database for PostgreSQL and pgvector. With all the craze around AI, I'm looking forward to see what we get to, what MJ Peña shows us here.
Hello there, everyone. I'm Ellyne Phneah. I'm a Microsoft MVP and MCT, Data and AI Director at Playtime Solutions. I'm here to talk about building enterprise RAG applications with Azure PostgreSQL. And if you're looking for something about embeddings, vector search, all things around LLMs, this is the right place for you. All right, let's get going. Now, here's some of the usual challenges that enterprise actually face. Now that we've come to that point where LLM is not a POC kind of thing anymore, right? Like every other organizations out there are already looking at exploring different capabilities around this particular technology. So one challenge would be obvious, is about knowledge silos. So different organizations are probably using different systems, different ways of communicating, different ways of storing documents. And most likely, there are a lot of transactional data out there already, right? So that's one of the challenges that most organizations face. They don't want to use yet another platform, right? They want more or less a consolidation exercise. Second would be the context gap, that LLMs usually lack a bunch of knowledge, right? Like obviously, these LLMs are foundational in nature. They are based off general knowledge, and they don't have access to your proprietary data. Then third would be about scale requirements. In some cases, if you try to introduce a bunch of these new technologies, it still needs to be battle tested. So, something like Azure Postgres or PostgreSQL, it's already battle tested throughout the, past decade or more than a decade, right? And lastly would be the security and compliance aspect, where we're talking about enterprise grade security and audit requirements, especially around the enterprise scenario, like, having capabilities around private endpointing and other enterprise use case. Now, within Azure Database for Postgres, it actually comes with a native vector search capability already. So that means that the managed solution of Azure Postgres is that it already comes with pgvector extension that you just have to enable. And you can use that to store and index vectors alongside relational data. So you can also perform various indexing and retrieval strategies, combining different vector queries with metadata filters. And you can have access control and other relational DB features as well that you're already having in your transactional database. Okay, so in the generative AI app scenario, mostly you can use this for RAG-based application or retrieval augmented generation, or you can also use this for recommendation or semantic search, which what we'll be demoing later, and of course hybrid search as well. So within this particular technology, right, Azure PostgreSQL, there are actually 3 kind of like indexes that are supported right now. So IBFF-lat, HNSW, and DiskN. All right. So without going into the details of all of this, right? So think of it like IB-flat is actually really good for, let's say, for small data set, right? And then HNSW is actually good for larger data sets. But then DiskN is kind of like a good, or I would say a memory optimized, and I would say a really production use case scenario that's for enterprise, because it has a lot of balance in between, that it's optimized for a bunch of use cases, especially around the filtering scenarios. Okay, so in Azure PostgreSQL as well, one thing that was kind of like important is that they've introduced this new concept again of having a integrated experience, right? So you can just have a kind of like select star from table, and within Azure Postgres, there's now this OpenAI and AI capabilities that you can actually use. So in particular, embedding. So instead of actually creating yet another pipeline or integration point with that, you can just use the create embedding, kind of like a wrapper method within Postgres, right? So that means that you don't need to create a bunch of different API layer of some sort. You can just implement this straight away. All right, so let's get going to a demo. Okay, so I'm using VS Code here, or Visual Studio Code, with a new PostgreSQL extension developed by Microsoft. So in here, I'm connected to my Postgres database on Azure using the flexible server plan. And I have a bunch of tabs in here where I'm going to kind of like give you an overview on how this actually works in practice, right? So this first tab here is just a simple prerequisite statement. And by the way, all of this will be shared later on. So you don't need to take screenshots or whatsoever, right? So first off is very simple, wherein you just have to check if the extension exists. And if not, you want to activate those extensions. Then from that, right, you can just verify if this particular extension are running. Okay, and you can see the versions around that. Then after that one, now you need to set up your Azure OpenAI connection. So it's as simple as just setting up your OpenAI endpoint together with the subscription key. Okay, so again, very straightforward. So it's a one-off configuration that you just have to perform, and you don't have to do it again. But at the same time, you can override this as well. Then once you have that, you can verify the connection, which in this case, I'm connected to this particular endpoint. All right. Then from that, you can also check the particular function signature that is out of the box, which is part of the create embeddings. So in there, you can actually see what sort of like arguments are supported in this regards. Okay, so in this particular rest of the section, this is just more or less, right, like pointing out that, hey, I do have a backup document already in place, and I have existing records in there, right? So from that, I can kind of like just perform a statistics of like seeing how many records are in there, right? Okay, so in some enterprise scenario, most likely you're dealing with tens of thousands of documents, not just 5 or 10, right? Then from that, what I did is that I created a separate table. So in this particular instance, right, I created a separate table called enterprise policies. And from that, I implemented this new column, right? So this new column, as you can see, now supports that vector kind of like native type, okay? So it's all integrated in there already, right? Then from that, I kind of like just perform a transfer of those records from the backup documents. And from that, just verify it if that's already copied. And then later on, right, I'll be performing an embedding exercise. So that's the second tab here, right? So in this second tab, this is all about embeddings. Okay, so first off is that you need to create an embedding. And the way it works is that it's very straightforward. Again, just using the create embeddings method, you just call that in. And for example, I want to embed this particular paragraph, right? So I'll just run that. And you can see the actual embedded value that I was able to produce, right? All right, I'm not going to save that. Okay. But kind of like this gives you an overview how quick and how fast that capability is. Right. Now, from that, you can kind of like perform how many records needs processing, right? Then after that, I've created this simple function that kind of like performs that embedding for you, right? So pretty much like this particular line 6 here, I've just encapsulated that to a function that would allow me to perform this concurrently in batches and stuff like that. Okay, so in this particular one, I'm trying to embed the policy title and the actual content of that one, right? So because those are the things that I want to use as part of the search criteria later on. Okay, so this, once you've defined that function, it's as simple as just calling that function and passing how many documents do you want to embed, right? So very useful, especially if you run this in a batch process. Let's say you want to do this overnight or during off-peak time, right? Then once you've done that, you can verify and check the status. Okay, so from that, what I've done is that because this particular instance, that embedding would take quite some time, especially for, let's say, 66,000 documents. What I did is that I've already created a separate table, which is if I scroll down a little bit, go back to tables, and you would see I already created a table which is a subset of that table with existing embeddings, right? So I've kind of like pre-processed this already. All right. So from that, the enterprise embedding. So what I would be doing is that instead of talking to that document, I would be talking to this with embeddings, right? So what I'll be doing is that I can just perform an actual text search, right? Which what we can use as a baseline. So within Postgres itself, without doing any vector, you can actually just perform a text search, right? So from a like-to-like scenario, let's say, hey, remote work policy, that particular word needs to exist, right? So yeah, that's why out of the box, Postgres and most transactional databases out there already support this, okay? But let's get going to the actual indexing where we can see a lot of these features in action, right? So in here, it's as simple as just creating an index, all right? So the concept of index is not really new, so it's been there for a while. It's kind of like a methodology that we've been doing to ensure performance or kind of like optimize the performance for our databases, right? So from that, you can just then perform an explain task to kind of like show you that performance, and you would see the result. Okay, so I'm not gonna run this because I have a comparison result later on. Then this one here, it's the same thing, but instead of the IBB flat, we're talking about HNSW, right? So from here, the keyword here is the using HNSW, right? And if you look at the IBB flat, is that the keyword there is to kind of like using IBB flat. And if you're doing IBB flat, you can also set the number of probes, right? Meaning how many lists of search do you want, right? The higher, the better accuracy, but it would suffer the performance. Okay, so now after that, I also implemented this scan index, which is the I would say one of the novel algorithm or technology these days around this space. Okay, and then in here, the keyword here is the using this scan for you to implement this, right? So if you kind of like notice, the implementing this index is very straightforward, right? You're just kind of like choosing which sort of like approach are you going to use. And from that, you can see the results as well, right? So to save time, I performed a comparison already. Okay, so in here, all I did is that I create a bunch of temporary table to store the performance results. All right. Then from that, the whole idea is perform a test and measure that test. And in this case, we're just trying to perform a search with, and how fast that search would be, trying to limit it to up to 10 search results. All right. So same stuff with IBB flat and HNSW and this scan. All right. So with that, we got this particular result. All right. So actually, before I show that, the particular search criteria that we're looking at is HR policies and procedures. Okay. So with that, what we've noticed is that when your test query is about HR policies and procedures, we were able to fetch 10 records per test. And what you would notice is that HNSW is actually so fast, right? Very fast. And then this scan comes in second. And what you would notice is that the IBFF flat kind of like falls at the last. All right. So the reason for this scenario is that the HNSW is fastest because we're just performing a simple, I would say a straight line search. And the reason why the IBB flat is also slow because we're dealing with a large data size, right? So it's kind of like, again, as I mentioned earlier, IBB flat needs to kind of like load things in memory. And that means that you kind of like have to perform that search. Again, the bulkier the memory that you're trying to push in, then the better result that you'll have, right? But given that we're dealing with a bunch of records, so IBB flat, IBFF flat kind of like falls in that particular one. And as you would see that there's a 76 times performance ratio between HNSW and IBFF flat. All right, really impressive. Now, you might be thinking, well, what HNSW is so great, why do we still need this scan, right? And this is the reason. So if I go to the next tab, right? So I've kind of like performed a similar test, right? Very similar test. The main difference this time around is that we're performing a category filter. All right. So and this is very important because in performing search, you need to also do filters, right? And a bunch of filters would really affect your performance, right? So that means you need a level of correlation, level of filtering, and enhancing your search criteria, right? So in this particular one, we're searching for the one with the category of HR guidelines, right? So same thing, I perform a bunch of test parameters in here, all right? And then the important bit is that when we go to the result, we would see that the average execution time of this scan is actually faster than the HNSW, right? And we're just dealing with, I would say, in the tens of thousands of records in here. But if you start working in, let's say, even in millions, you would see the gains of HNSW, disk N way more, I would say, performant than HNSW. All right. So that's why, if, in this particular instance, if it's a little bit more complex or there's a filtering scenario, disk N is really the preferred choice. All right. So now to close off, I just want to mention as well that in Postgres SQL, with all of these vector capabilities, it's also capable of doing semantic search, so that you don't need another external services for that. So this is a very simple activity. So just create a semantic search function. All right. Then from that, you basically just perform a rounding based off the embedding and the vector result, right? So from that, it's as simple as, hey, let's talk about all things about data access and security. So in this regards, right, I was talking about data protection, right? So let me run that. So if I'm going to perform a semantic search on data protection, you would notice that the particular query is actually fast, right? Because technically you're offloading, or you're putting the pressure of that search within where the data lives as well. That's why it's relatively fast. Now from that, you would see that, although the data word is in there, but the other word, which is protection, you get kind of like a similar sense of semantic result out of that, right? So around sensitive, authorized, restricted, right? And all those type of things. Okay. So that kind of sums up the whole idea of all of these things being part of Azure PostgreSQL, right? So again, just to recap the couple of things. One is that all of these are built in. You don't need an external system to do this. And in terms of prerequisites, all you gotta do is that you have to enable these extensions, and then set up this Azure OpenAI settings. Then after that, you just need to create a bunch of, I would say, indexes, right? And perform embeddings, right? And then from that, you can kind of compare which is the best use case for you. But in summary, right, the best use cases would be use the IBFF flat if you're working with a small data set. Use the HNSW for performing kind of like a larger data set, but relatively speaking, it's a straightforward search, right? And then use DiskScan, I would say, for a much more complex search that includes a lot of filters, right? So, and the beauty of DiskScan as well is in terms of cost, performance, and stuff like that. It's really well optimized in a real production workload. Okay, so with that, thank you very much for attending this particular talk. And if you have any questions, please feel free to reach out, comment below, or please like and subscribe. And I'll see you soon.
Thank you so much, MJ. That was a really interesting talk. It's a brave new world, seeing what people can do with these, with extensions. And actually, I happened to pick, when I was working on streaming I/O for Postgres 18 and 17, I happened to pick the pgvector HNSW index somewhat randomly as a popular extension, just to see how it could be adapted to use asynchronous I/O, and finished up learning a bit about all that stuff. And it's a really interesting topic. There's so much interest in it right now, and the things you can do with it are incredible. It still kind of amazes me that a computer can do these kinds of things. So yeah, thank you very much. Great talk. Don't forget to fill in the survey if you're watching, building enterprise RAG with Azure Database for Postgres and pgvector.
Sorry, I jumped the gun with the slides a bit. I believe we have a trailer running right now.
Hi everyone, and welcome to the 4th year of Posette and a map for Postgres. My name is Charles Pedersen. I'm the Director of Product Management for Postgres at Microsoft, and I'm pleased today to be able to tell you about all the things we're building in Postgres at Microsoft in 2025.
Hi, my name is Robert Haas. I work at EnterpriseDB, where my current job title is VP Chief Architect Database Servers. And my talk is about incremental backup, which is a new feature that I developed for PostgreSQL 17. I'm hoping that this feature will be of particular interest to people who have large databases and they're looking for some new backup and restore options.
Hey, hello, my name is Boris Mejias in the role of Monica de Bea.
And I'm Sarah Conway in the role of Evelyn Cates.
And the reason that we are saying in the role of is because this is going to be storytelling. We are going to tell you the story of a developer who comes and seeks help from a DBA who knows a lot about databases, and together combining their knowledge, they are going to be able to provide data integrity through data modeling.
As you can imagine, if you're an application developer or a DBA or anyone in between, even if you're just interested, you can definitely benefit from this talk.
So, hello, my name is Tomas Wondra. I work at Microsoft. I'm a long-term Postgres contributor, developer, and also a committer. And I'm here to talk about performance archaeology, which is an overview of how the performance of Postgres changed over the many years of development. So if you are interested in performance and are a user or a developer, this talk might be interesting for you.
I'm Pamela Fox, and today I'm talking about building modern Python web apps with Postgres. If you've ever thought about building a Python web app and you're trying to pick the technology stack, then this talk is for you.
Hey everyone, I'm Matt McFarland, and I'm an engineer at Microsoft and a contributor to the new VS Code extension for Postgres that's just been released to public preview. Please join this talk if you're interested in learning about a new tool in VS Code that can help manage and you develop Postgres applications using both standard database management tools and also more advanced Copilot AI capabilities.
I'm Luke Swittle, founder and CEO of PG Analyze. We're going to talk about how to optimize slow queries in Postgres. Specifically, when you have an explain analyze output and you don't know how to interpret it, I'm going to give you a few tips and tricks and a better mental model for working with slow queries in Postgres and how to fix them.
Everyone, I'm Bohan Zhang. I'm a member of technical staff at OpenAI. In this talk, I will discuss how we scale Postgres to the next level at OpenAI. Specifically, we will talk about how we operate Postgres and the lessons we learned and the challenges we face and how we address them at OpenAI. If you are a DBA operating in production Postgres at a very large scale, you might be interested in this talk.
Hi, I'm Vinod. I'm a partner software engineer at Microsoft and one of the committers of Microsoft's DocumentDB. And today, I'll be talking about designing document databases for PostgreSQL, aka how we leverage the awesomeness of Postgres' extensibility model to build Microsoft's DocumentDB.
Hi all, my name is Gayatri Padalla, working with Microsoft as a PostgreSQL performance expert. Boosting the PostgreSQL server's performance using Azure Advisor recommendations is the best way to identify any vulnerabilities your server is going through. You will be informed proactively, and anyone who is moving from Oracle who is not aware about the internals of the PostgreSQL, for them this is the best approach to identify their server's vulnerability and get it fixed.
Hi, my name is Philippe. I'm one of the founders and the CEO of FerretDB. Today, my talk is titled Elasticsearch Quality Full Text Search in Postgres using Tentivy. We're going to be talking about how you can do full text search in Postgres today, what it's amazing at, what it's perhaps not so good at, and then some of the ways in which the work that we do at Parade with an extension called pgsearch is lifting the limitations that full text search in Postgres has to make it competitive with Elasticsearch and other search engines.
So that was Livestream 1. You will be able to see all the recorded talks from it, so don't worry if you missed that. Now we welcome Peter Farkas. Peter is at FerretDB, but he took part in Percona and other companies. Today, Peter will tell us about building Mongo on top of PostgreSQL essentially. And there's a long-running joke in the community that PostgreSQL is better at document the storage than Mongo itself. So I'm wondering if that will be answered. And it's also a very nice tie-in to the topic that showed up, brought up by Amit in the hallway track. He quoted, I believe, Michael Stonebaker, what goes around comes around, which is the everything old is new again topic. So it's close to my heart. I'm looking forward to learn more about this.
Hello everyone, my name is Péter Farkas. I'm the CEO and co-founder of FerretDB, which is an open source alternative to MongoDB. And today I'm going to talk about turning MongoDB into an open standard and implement it on Postgres. So if you're a MongoDB user, if you're a Postgres user, if you are both, then you might be interested in this presentation where we combine the power of these two database technologies. All right, so let's dive in. So today I'm going to talk about MongoDB as an open standard for document databases. So the reason I'm very interested in this topic is because the reason why we've built FerretDB and the reason why we've been doing what we're doing for close to 3 years now is because there is a group of users who chose an open source database. They chose MongoDB as their main database. And I will be talking a bit more about this later on. When MongoDB changed the license to their SSPL license, which is not an open source license, then they basically found themselves in this situation where they chose an open source database and then they ended up with a proprietary one. And we think that it can be replaced by Postgres on the long term, MongoDB, that is. So, quick introduction of the company. I promise I will not talk much about the company itself. So we have three co-founders, Alexei Palaschenko, Peter Zaitsev, and myself. We all came from the company called Percona, which is an open source database consulting company you might have heard about. So, just a quick recap of our agenda today. We are going to talk about MongoDB's licensing, the history of SQL as an open standard, the MongoDB query language as an open standard, the architecture of FerretDB, and then we will conclude the presentation. So this is the Stack Exchange Developer Survey of 2024. Or a little portion of it concerning databases. And so this survey asked developers, which database environments have you done extensive development work in over the past year, and which do you want to work in over the next year? It had 67K responses, so a pretty representative survey if you ask me. And so the result of this survey is very interesting. First of all, it's not a surprise that Postgres was by far the most coveted database technology among developers. Then it was MySQL, SQLite, MongoDB, and Microsoft SQL Server. So there is one outlier on this graph, and well, judging from what my presentation is about, you might have figured out that it's MongoDB, but why is that? So the reason why MongoDB is an outlier on this graph is because, first of all, it is the only document database, and second, among its peers, it is the top one database, but not open source. So Postgres, MySQL, and SQLite are all open source, but MongoDB isn't. So basically, if you want to work with a document database and you want to work with the top document database, your only choice is really a proprietary database. So whenever I present a similar or this presentation, the question comes up, wait, isn't MongoDB open source? Because, of course, MongoDB started out as an open source database, and lots of users liked it, and it gained market traction because of its open sourceness for the most part. But they changed the license in 2018 to this license called the Server-Side Public License, or SSPL. And SSPL, while MongoDB claims it's an open source license, it is not recognized as such by open source organizations such as the OSI. The reason why it is not regarded as an open source license is because it doesn't come with the same freedoms as most open source, or well, all open source license should. Mainly, it discriminates against use cases. So, for example, if your MongoDB database is used as part of a cloud service, then you might be in a situation where the SSPL would mandate you to open source your entire stack, or SSPL your entire stack, which is used for that, for providing that service. So that doesn't make me remember how open source licenses should work. You can also decline to SSPL your entire stack, but then you will have to pay a license fee. So why do we even care about that? You can just SSPL your stack and call it a day. Well, the reason why users should care about the SSPL license, the reason why this is bad, not just for service providers like Amazon or Azure or whatever have you, is because it kills innovation and creates vendor lock-in. So if you think about it, the less providers you have who are licensed to provide MongoDB as a service, the less competition there is on the market. And if there's less competition on the market, that means less innovation and higher prices for the users. So there is this website which tells you more about the effects of SSPL on the broader user community. It's ssplisbad.com. I don't know who created that website. I don't know anyone who would be affiliated with it, but they did a pretty good job with explaining what's up. So we established that MongoDB is no longer open source. Let's ask the second most common question: why not just use Postgres and JSON? Because there's JSON support for document workloads in Postgres. So in theory, you can just depart MongoDB and use Postgres. Well, in reality, it's harder than you might think. So MongoDB dominates the document database market, and so a lot of frameworks, a lot of existing applications, a lot of tools, and of course, the skills and knowledge of developers are built around MongoDB. So that means that it's pretty hard to not just rewrite applications, but also to relearn lots of the skills and knowledge needed to build applications for the sake of using Postgres might not be feasible for many organizations. So JSON support is great, but the existing frameworks and the existing developers might not be comfortable with what it offers. So Today's presentation is also going to be about the short story of SQL, and I promise that it is going to make sense moving forward on why I'm mentioning this. Some of you might already have figured out the why, but of course this is a short presentation, so it's not going to be historically accurate, but still my aim here is to provide a quick recap, so it will provide a bit more context to this situation with MongoDB. So the short story of SQL, the short history of SQL, well, it started, SQL has a long history. The reason I'm saying short history is because what I'm going to present is the very short version. So IBM came up with the relational model and with SQL as well. The relational model was developed by a person called Edgar, or Ted Codd, who was a researcher at IBM Research Labs. So he came up with the relational model, which we all use in Postgres. And he also came out with the first query language for this relational model, which was crazy complicated. You actually had to write an application, a separate application to query data from your relational database. So while it was a groundbreaking new model in database technology, the query language was very complicated and could only be understood by hardcore developers of the time, not end users for sure. So this was in the 70s. So also in the 70s, there were two other colleagues of Edgar Codd at IBM, Don Chamberlain and Ray Boyce, who recognized this problem with the relational model, that there is no viable query language for end users. And they came up with SQL, which is this very easy to use English-like query language for relational databases. And this is what really enabled the relational technology to gain traction, because finally there was an easy to use way to query your data from and also to insert it to the database. One very sad but interesting addition is that Ray Boyce was 20-something years old, and he actually died of a brain aneurysm shortly after publishing the paper on SQL with Don Chamberlain, and so he never had the opportunity to learn the profound impact he had with this paper on the world of information technology. In any case, SQL and the relational database gained traction on IBM computers. So it ran exclusively on IBM computers, and the product was named IBM DB2. Some of you might be familiar with this product. It's actually an interesting one. So IBM released the IBM DB2 product on their machines, and you had to lease these washing machine sized computers if you wanted to use this technology. So if you liked SQL, you had to lease one of these. You couldn't run it outside of an IBM environment. Does this make you think that we might be doing the exact same with cloud and all that? So you had to lease someone else's machine to run the software you're skilled in and what you like. In any case, if you wanted to use a relational database those times, you had to use IBM. And then some others came up with alternatives as expected. So there was Informix, Sybase, or a relational software systems Inc., which is nowadays known as Oracle. So these alternatives appeared on the market, and these were an implementation of the relational model and SQL. However, these alternatives were not based on any kind of standard in connection with SQL, which meant that they implemented it based on the behavior of IBM DB2 or based on what they saw fit on how this should work. So at the end of the day, they came up with similar products, and this was really helpful to users. However, there was no conformity between these products. If you knew SQL, you kind of saw a similarity between these products, but they were not compatible with each other. But at the end of the 80s, SQL was established as an open standard. So finally, vendors and researchers and users came together, and they created the SQL white paper, which described how SQL should be implemented, how it should behave. So if you were a user and your database product had some degree of conformity with the SQL standard, then you could have expected similar behavior. And that's when this open standard enabled open source projects like Postgres, like MySQL, like SQLite, and hundreds of different derivatives of the SQL standard to be implemented in a way which could be used by many more users across many different systems out there. So when SQL became an open standard and when open source projects picked up the SQL standard, that's when the relational model and SQL got this chance of word domination, where anyone with a computer could use the relational model, benefit from it without fear of vendor lock-in. So I promise that it's going to make sense for me to start describing the history of SQL. And so let me explain why I did this. So you might think that this is just a distant memory where, you know, you lease washing machine-sized machines just for the sake of using a database technology you like and you're comfortable with. But actually, this is the reality of lots of users around the world, lots of developers around the world. So this is not just the thing of the past. If we look at document databases, as I mentioned earlier, MongoDB was an open source database, so many users chose it for the sake of avoiding vendor lock-in. So it's rather different from SQL, which started out as proprietary. But in any case, MongoDB is no longer open source. If you want to use it, you need to use MongoDB Atlas or some cloud service, or the less feature-rich community edition. But still, you are unable to use it as a service, for example. So you have to lease someone else's machine as part of the cloud, or you have to make sure that you abide by the SSPL license in order to use MongoDB. So MongoDB had very similar promises. You don't need to be a DBA to run a database. It's much easier than the database technologies of the time, or relational. So it had very similar promises as SQL itself back then, and that's why it captured the attention of many developers out there. So there is this very interesting similarity between the history of SQL and MongoDB, where after the license change in 2018, lots of alternatives appeared on the market. I think this slide might be very familiar. It's just I replaced SQL with the MongoDB query language, or MQL, and the alternatives are also well, not so much compatible with each other, because even though these alternatives you can see on the slide all did a great job in trying to mimic the behavior of MongoDB, they are not compatible with each other. They don't share the same or similar feature set, and in many cases the behavior is different. So if you're a MongoDB user, that doesn't mean that you can just get out of your vendor lock-in situation by switching to one of these. It might be possible, but it is very likely that you will have to relearn some things, and you might also need to do a rewrite of your application. So once you choose one of these, you're kind of stuck with that. So the issue with MongoDB alternatives, and this was a problem with the SQL alternatives as well, is that the feature set is different. The compatibility is not quite there between them. Migration is hard, and these alternatives might also be tied to specific cloud vendors. But for the most part, using an alternative of something is also challenging, because for the alternative, the original implementation sets the pace. So what if MongoDB deprecates something? Will alternatives need to deprecate that feature as well? Or will alternatives need to share the same developer roadmap with the original implementation just to stay compatible? Sometimes that doesn't make sense. So this is why I think that we are in need of a new open standard, a very similar standard to SQL, which explains how MongoDB or MongoDB-like document databases should operate. How I imagine this, or we imagine this, as there are quite a lot of vendors and developers out there who are looking forward to this, would be a standardized core feature set based on MongoDB, a JSON-like query language, and basically a core which explains how the database should behave, which could be extended of course, beyond what the standard mandates, just like with relational databases. But establishing this core would ensure that there is a possibility to migrate between these products, to use the same skill set you have to move to any alternative which implements the standard. And this would stimulate innovation and increase competition to the same degree, or a very similar degree, as how it happened with SQL. And that's why I talked about the story of SQL in today's presentation. So as the SQL standard was really good for users, we believe that a standard around document databases would have a similar effect. So what did the community do, and what did we do to make this happen so far? I promise this is not going to be a sales pitch. Of course, I'm affiliated with FerretDB. We think that FerretDB was one of the first steps towards this standardization, since we developed a MongoDB compatibility layer, a fully open source one written in Go, which uses Postgres as the backend. So we basically turn Postgres into a MongoDB compatible database, which can be used anywhere, and it comes with the same freedoms as any other open source database, as it is released under the Apache 2.0 license. Well, that's a real open source license without strings attached. So what we mean by MongoDB compatibility, it means that existing elements of the MongoDB ecosystem, so that is a tool or application or framework, are possible to use with FerretDB or any of the compatible alternatives, meaning that developers don't have to relearn their database technologies. They don't have to rewrite their applications. If you connect to FerretDB, which stores data in Postgres, well, it behaves just like MongoDB, meaning that your application will not even notice that that it is not running on MongoDB proper. So MongoDB compatibility means basically the freedom to migrate away and migrate your MongoDB workloads to Postgres. Just a very quick kind of overview on the architecture and licensing. So as you can see on the top chart, this is how MongoDB looks like from a licensing perspective. The MongoDB drivers are Apache 2.0, and the Mongo API and the database engine, which was called Hitchhiker, it was purchased by MongoDB for the purpose of the database engine behind the MongoDB experience, are licensed with the SSPL license. So the MongoDB drivers are or may be part of the application developers right, meaning that the license can't really be changed to SSPL. And the MongoDB drivers are the well, that's the portion which really provides this smooth experience for developers to develop for MongoDB. And so, since it's still Apache 2.0, if you look at the bottom chart, we can just use these MongoDB drivers to interface them with FerretDB instead of MongoDB, which emulates the MongoDB API, which then interfaces with Postgres or the well, Microsoft's DocumentDB extension. And these are all licensed as either Apache 2.0 or MIT, or well, the Postgres is licensed, meaning that the full experience would again be open source. So that's why we want to bring the MongoDB experience, to bring MongoDB to Postgres, and that's how we did it. The interesting thing about FerretDB is that since we turned Postgres into a MongoDB compatible database, we can also turn Postgres as a service providers into MongoDB as a service provider just by running FerretDB on top of their Postgres offerings, which was the very thing SSPL did not allow providers to do, meaning that users of these platforms or any Postgres provider can leverage the power of MongoDB and use the same provider for both Postgres and their MongoDB needs. Another huge step towards the standardization effort here is that we had the pleasure of working together with Microsoft. It took more than a year to release FerretDB 2.0, which uses the same engine as Azure Cosmos DB for MongoDB, which is an open source alternative to MongoDB built on Postgres. And so FerretDB 2.0 is largely compatible with Azure Cosmos DB for MongoDB, meaning that the current alternatives are moving closer and closer to provide a common feature set. And so it enables users to switch over or switch between these two MongoDB alternatives, which was previously not possible. And this is how standards are being born even before someone writes a single line of text into a white paper. We also have the OpenDocDB effort at opendocdb.org, which is a community-led push for standardization. We think that it might make sense to certify compatibility first and write the standard later, meaning that we have a tool which looks at the current alternatives, either FerretDB or Azure Cosmos DB or AWS Document DB or Oracle's MongoDB API. It compares the feature set of these, and we are coming up with a common feature set which these alternatives will be tested against, and then we can say whether these alternatives are compliant with the OpenDocDB requirements or not. Kind of similar to how some of the web-based standards were born in connection with CSS or even HTML. And this effort is supported by quite a lot of companies in the Postgres community, and I would invite you to visit the website to learn more about our manifesto and this effort and this standardization in general, especially if you would like to take part in it. So the conclusion, there is a need for an open standard for document database as far as we believe. We think that MongoDB is going to be the same kind of commodity just like SQL is. We do build this with the community, whether that is FerretDB as an alternative to MongoDB based on Postgres, or the standard itself. So if you would like to join this effort, if you're interested, please don't hesitate to reach out to us, to try FerretDB, to look at the current progress on GitHub. And if you would like to connect on LinkedIn and talk a bit more about this, then I'm more than happy to do that as well. With that, thank you so much for your attention today, and I wish you a good rest of the conference moving forward. Thank you so much.
Oh, that was a really interesting talk. Thank you so much, Peter. Interoperability is such an important thing in our industry, and yeah, that I learned a lot from that talk. Thank you so much. So if you'd like to fill in the survey from MongoDB to Postgres, building an open standard for document databases is the title to look for. Go and do that. You might get some socks. And our next speaker.
And maybe before we jump into the next speaker, let's remind people about the virtual hallway track that we have running. So you can follow the link on screen or the QR code. But I will try to show you on my browser. So if we bring up my screen, this is the Posette website where you likely are watching us now live. I'm not clicking play to avoid, the mirror effect of infinite versions of us appearing on screen. But you can see the chat running on the right here, and it's pretty active. Fun topics. There's a Stonebaker paper linked here. There's discussions. Peter that just finished his talk is present and answering questions. So please drop by. It's very easy to join. Click join Discord. It's a quick setup. We are waiting for you there to have a chat. So with that, let's go back to the slide deck.
All right. So Adam Volk himself is now going to change from host to speaker with Hitchhiker's Guide to Row-Level Security. Row-level security in Postgres in general, I believe, but also in Citus.
Yes, both, actually. Yep.
All right. Take it away, other you.
Hi everyone, my name is Adam Wolk. I'm a Principal Technical Program Manager for PostgreSQL here at Microsoft. Today I'm going to tell you how to travel using row-level security with PostgreSQL and Citus. So grab a towel and join me if you want to learn how to use row-level security with your application. Hi everybody, don't panic. We're going to learn about row-level security in PostgreSQL and in Citus today. So just like a towel, row-level security is a useful tool. Imagine you're on a beach and you need to cover some private parts. Then if you have a large enough towel that's just right, it will do its job. It will hide the pieces that you need covered, and same with row-level security. Things that need to be hidden will be hidden. If you wrap yourself too tightly, then you will be encumbered in some way, and with too complex policies that you employ in PostgreSQL will slow down your database. It won't be able to move as fast as it used to. You can have a too small towel and then it will cover too little. People from the side will be able to get a glance on things that they shouldn't see or infer what's there. And it can be too big, essentially covering you wholly, and then somebody will step on you because they don't know that you're sunbathing underneath a towel. And the same can happen with row-level security. If you cover everything and want to do a backup and then all the rows are hidden, then you don't have a backup. So we're going to touch upon some of those aspects also. So you can think of row-level security the same way as a SEP field. So as soon as you enable it and have some policies in place, the rows that are under the policy become somebody else's problem. You will no longer see them, or they will no longer see them. Now, there's some cases where somebody can see through the SEP field, through the row-level security. If you're an owner of a table, you're exempt from the row-level security policies, and you can see all rows. You can change that with the force setting. So if you tell alter table force row-level security, even you as the owner will be forced to obey the policies. Now, some other users essentially bypass it. Like anyone with a bypass RLS row-level security role will be able to bypass it. Also, the super user will be able to bypass it. And there are some mechanisms of PostgreSQL that simply ignore it. For example, the truncate command or any foreign key references, but they need to do it to provide integrity, essentially. And there are some leak-proof functions that can leak data that we may touch upon later. So defining row-level security policies, that's something like every wagon's bureaucratic dream to define policies. By default, the policies are ignored. Like if you create a policy and don't enable row-level security, it's just there. You define a policy per table, so every table can have its own set of policies. You can reuse the name across different tables, but obviously unique on the same table. There are two types of policies you can have, permissive and restrictive. By default, if you have no policies, it's deny all. Permissive policies are required to say you can access a row, and you need at least one permissive policy evaluating to true to see any rows at all. And if you have multiple permissive policies, they will be chained together with an OR clause. So if you have 5 permissive policies defined, you need just one of them to evaluate to true to be able to see a row. Now, if you have restrictive policies, they are the opposite of that. They tell you for whatever you are allowed to see, remove, make sure that we don't need to remove more. Right? So they restrict what you were allowed to see. And they are chained with an AND clause. So if you have 5 restrictive policies, all of them need to pass for you to see the row. And if any one of them doesn't pass, then you're not allowed to see it. To see any rows at all, you need at least one permissive policy passing and all restrictive policies passing. There's no point in having just restrictive policies, so you always need at least one permissive. Now, policies can be defined for all commands, a subset of them. Like you can decide, well, I want a policy for a select and a delete, but I don't care about insert and update. Or you can define them for a single one of them, however you want. Policies can also be defined for everybody in the database. So for the public role, which is the default, or for a specific role, user, whatever you define. Now there are two clauses that takes expressions. So you have a using expression, which essentially applies to existing data. So it would apply to select, update, and delete because they work with existing data. And the with check would be used for the newly added data, like an insert statement. It gets tricky with the merge command because it will apply to a mix of both, right? If you're doing a merge command that can result in an insert or update or an upsert or something like that, or a delete, merge with delete, then it will use the appropriate policies and appropriate types of commands that were defined for it. If you don't provide a with check, it will use the using clause that you define. So if you skip this with check, it will use the using clause both for newly added and existing groups. Now there's also this GAC. GAC is like a user configurable variable in PostgreSQL called row security. That's very misleading, and it tells you, like, you can set it to off, and what it does is it doesn't disable row level security. What it does is it tells you, if I run a query now, would this query be limited by the policies of row level security? And you can see here we have a table, literature entries. We select from it and we see 2 books by Douglas Adams, and we turn row security to off and do the same query again. And now we get an error that, hey, this query would be affected by row level security policy for table, blah, blah. Now, maybe you see a gap between 1 and 3. So, and it says that there are 2 rows. We don't know if there are 2 rows, but maybe there's more. Maybe some policy hides that row from us. This is useful for the too big table example. Like if you're doing backups, you want to make sure that you exported all rows. So knowing that something would be hidden is useful. And this is actually something that pgdump is doing when it's doing an export, to make sure that you're not tripping over your own towel. Okay, so that's row level security with PostgreSQL itself. Now with Citus, Citus is kind of cool. Citus brings some alien technology back to PostgreSQL so that you can get your standard PostgreSQL database and expand it horizontally across multiple machines, just like a Galaxy expands. And you can do it by schema or by row, and we will focus by row in this specific presentation. So think of sharding as in like partitioning. So imagine you're taking a table and deciding, I'm going to take a column of this table and designate it as the distribution column. So I'm going to split the table based on the values of that column. And that way you end up with many small tables. Let's call them shards. And the magic in Citus is that it allows you to move shards to a different machine, and all machines in the cluster know where every shard is. So if you ask any machine about any data, it knows where to go to get that data back to you. So because I'm lazy and I have it handy, I'm going to use Elastic Clusters, which is essentially Citus available on Azure Database for PostgreSQL Flexible Server. And it's the standard Citus that you can use and deploy yourself. What it does actually is, like the difference is that we added this special port 7432, which actually load balances any connection that you may make to any node in the cluster. And that way you can scale your workloads by splitting up the incoming traffic onto many nodes and have every one of them act as the single, like as a coordinator node, essentially. So imagine that in the bustling data hubs of the galaxy, there is this pan-galactic biblioteca that maintains a table called like literatural entries that we saw before to store books, poems, and other like countless creations. So this is the table. It's very basic, but we also know that some of these will be the dreaded works of Vogon poetry, and these can cause distress to anyone who read them. So it would be nice to have some form of preventing people from accidentally reading Vogon poetry. So we add a content rating, and this ode to small lump of green potty is abstracted part of a Vogon poem that we want to prevent people from seeing. So we will have safe as the content rating for any non-Vogon poetry, and Vogon poetry essentially for Vogon poetry. Next up, our prosthetic Yields Jr., the author of the database, a well-meaning but slightly careless DBA, will try to define some roles and policies on how to access this table. So we can see a critic role, a Vogon bureaucrat role. These roles are no logging, they are used for grouping permissions, and we create a very simple policy on the table allowing you to read safe poetry, and a policy for Vogon bureaucrats allowing them to read everything if they want to. And of course, we enable role level security. Prosthetic Yields made a mistake of not doing force row level security. So as the table owner, when he tested this and ran select start from table, he was exposed to the full length of the Vogon poetry and ended up essentially hospitalized for the remaining time. So please remember to apply policies. So row level security with Citus itself is the same as with PostgreSQL. There's really not much different because Citus is magical in a way that you can do almost anything that you can do with Postgres. But there are some good practices that you can do when using row level security with Citus itself. The first thing is there are two ways you can set up policies. One way is to use role-based policies, let's call them that. So you can see here I have a example based on like the standard Citus tutorial with companies, ads, and campaigns. And I'm trying to limit every tenant of the table to access its own rows. So I'm defining a policy on every table that's for all commands, and I'm allowing the current user to execute that command only if their user name, the PostgreSQL role, matches what's stored in the ID column or company ID column, because this data is distributed based on company ID, essentially. This is nice because it limits access down to protocol level. Like you connect with the user, you have access or not. And there is not much you can do about it in terms of swapping tenants. The problem with this is overhead, like you're adding a lot of users to your database, so that may be cumbersome. And the other problem with that is you have more connections overhead because you cannot multiplex a single connection onto multiple tenants. But that is very useful when you, for example, have an application and want to give a tenant direct database access to your system so that they can do ad hoc queries without the risk of them snooping around on other tenants. Another approach common for doing row level security with Citus would be a set local based policies. So you can use PostgreSQL settings and introduce a custom setting like myapplication.companyID and set the company ID to the tenant that's going to use the database. And here, everything is the same except that we're reading the current setting of this value and comparing it with the company ID. So querying that data with setLocal setup is very simple. First, in your connection, you need to enable propagate set commands to local so that local commands are propagated. Then you open a transaction. Within that transaction, you set local variable company ID equals 5. And then you can do a query for that company ID. And you should be able to see those rows. But if you try to query for a different row, that row won't be visible. Like if you tried company ID 6 with this value being set to 5. There's a gotcha with Citus before version 13.1. In version before 13.1, if you're doing grant permissions with this with inherit option or with set option, these won't be propagated to all nodes in the cluster. That changes with Citus 13.1. But in previous versions, if you want to use something like this to essentially assign rows, you will need to disable DDL propagation and use the run command on all nodes to essentially execute this command on every node in the cluster. That's just an easy way to do this. Okay, so now that we've got all the theory out of the way, we can actually jump into seeing both things in action. So we will going to do the Vaughan poetry example, and we will do the row-level security setup with the campaign stable for Citus. So let's swap to a friendly PostgreSQL terminal, and I'm here connected actually. I can connect here to my remote cluster, running Citus on a 2-node machine. Let's swap display so that it's better visible. So you can see I have 2 nodes, this node on port 7000 and this node on port 7001. And I took the leisure of creating some tables. So ads, campaigns, companies, literature entries, and even reviews. And what we are going to do is, first off, we are going to just select from this table, from literature. So we can see all the 3 rows, including the Vaughan poetry row. And this is because we haven't enabled row-level security yet, and we haven't defined any roles. So if we connect to this database, for example, not as me, but as Arthur, we can also see that Arthur is able to query the whole table. So if we swap the display, we can see he unfortunately can see Vaughan poetry, and we don't want that to happen. So let's connect back. Let's enable low-level security on this table. And if you look at it right now, you will see that the policies are enabled. And that should change how things work already. So let's connect back as Arthur. Let's filter and do a query. We can see that we have no rows because by default with no policies, nobody can access anything. So let's define some policies. So I'm going to execute create policy that we saw in the slide deck. This creates 2 policies. You can review them on the table. Policy for select save, and policy for Vaughan access for Vaughan bureaucrat to do everything. If we connect now as Arthur and try to read from this table, we still have no roles because we didn't assign any role to Arthur himself. If we go to our my super user account and check what role assignments I did, you can see that Zapot is a critic, Marvin the robot is a Vaughan bureaucrat because, hey, robots don't care about reading Vaughan poetry, but just for the sake of it, we prevent Arthur, the regular human being, from reading anything stored there because maybe he sees that Earth is bound to be destroyed in 50 years and maybe files a complaint, and the Vaughans wouldn't be happy about that. So what can we do here? Let's connect as Zapot and see the same table, we can now see that, and I'm going to swap displays, we can now see that the Vocal poetry is hidden properly. So the rule that we defined is fine. And if we connect as the Marvin robot and execute the same query, we can see the additional Vocal poetry being shown. Now, but Zapad is a very curious fellow, and he noticed that there's this reviews table that doesn't have row-level security, but has a foreign key reference to literature, to the entries table that stores all the data here. So the question is, can I insert into reviews where, and I need to select so that I have some, yes. So can we add a review for the first entry in the books table, but good book? I can, if I write without errors, which is reviews, sorry. So I was able to add a review for the first entry in the books table. I can add it for the second. I can add it for the third book. And I cannot add it for the fourth book. So what happens here? If we select a Zapad from the entries here, we only see 2 entries, but we were allowed to do more. We were allowed to insert the second row. So knowing this, we just figured out, okay, if I provided an ID that doesn't exist, I would get a foreign key constraint error. I didn't, so entry 2 must exist. And that way Zapad found out that on row 2, there's probably something hidden. Now, this may or may not be a problem. This is like a side channel leak, essentially somebody using the knowledge of something is there to figure out if it's there or not. That may or may not be a problem, but keep that in mind. You can, of course, design around it. You can make sure that you cannot add reviews for rows that you shouldn't see, etc. But just keep in mind when you're designing your security policies, what type of information can be figured out by the act of not seeing everything. Okay, now we can switch to the Citus-based example. So we're still connected to the cluster. Let's make sure that I connect as my super user. We see several tables. Currently, there's no policies in place. So let's enable row-level security. So this is very simple. Alter table for every table. Enable row-level security. Now we have row-level security enabled, but with no policies. So what does that mean? That means that right now I can connect as 10 with 42, and I can do a query like this for company ID 5. And I enabled row-level security. So since there's no policies, I see no data, neither for this tenant or for my own tenant. So if I do 42, I still see nothing, right? Now, if we want to fix this, we need to define some rules. So let's define the role-based policies. Policy role-based. We saw it in the slides. This compares the current user to tenant underscore ID of the company. So roles are now created. I did cheat and I created 100 tenant something users beforehand so that you don't have to wait for him to create them now. And of course in a scripted manner. But let's connect back as the tenant 42 user. And let's try doing this query again. which is, hey, I want to see rows from 10 and 42. And suddenly we can see the data. And this is very bad. But I have a meeting starting right now. Okay. So if I switch to company ID 5, we can no longer see the data because I'm connected as 10 and 42. And if I select from the company's table, all I see from the company's table is 10 and 42. If I reconnect as 10 and 13, the only data I will see when querying the company's table is rows for company 13. There's no additional, there's no other way for me to access any other row in these tables because my access is limited by the policy that we defined, that I have to be this user to access these rows. Okay. So let's drop this policy. Typo. This is just drop policy name from the company's tables. And let's define the second policy, which is the set local based policy. So now with this policy in place, if I'm connecting as advertisement user, for example, so not like nothing related to the tenant setup that we had before, and I do a query from companies, it will fail because I didn't define this set local variable. So what I need to do is query set local. First off, we disable the set commands. Then we open a transaction, set my ID to this company ID 5, then do the query. So let's do this. And we can see a lot of results. Now we can try to do this manually. So I'm going to open a transaction, set local my app company ID equals 42, select all from companies, and I see, I'm going to change the display, and I see only record 42. Now if I change the app ID to 13, and I do the query, I can see data for a different tenant. And as you can see, I can reuse the same connection. So from the application's perspective, that's nicer because it's easier to handle this without additional users. But if you're allowing somebody direct access to the terminal, then that's harder to manage and filter off, essentially. So with that, you should be set up for your travel with role level security. Grab your towel and go try it out.
Wow. Great demonstration. A lot of this is stuff from the SQL standard as well, if I'm not mistaken. Yeah. So some amount of portability across systems. No doubt lots of hidden complexity.
Yeah, and I will be, of course, in the chat answering questions in between us talks are running. And please remember to do the survey. I would appreciate your feedback, good and bad. I can take the bad feedback, don't worry. And you may get socks for it, so a win-win. So with that out of the way, let's welcome Cédric Villemain, I believe, who will talk about resource control admission and having a date with the PSI. And I'm very interested about that. I believe this is some form of an ability to do resource governance with PostgreSQL, which is a very desired trait. So I'm really looking forward to this.
Hello, everybody. I'm Cédric Villemain. I'm the president of DataBene, which is a French company providing PostgreSQL expertise worldwide. And today I have a date with my FC, and I believe you have a date with my FC too, because you're attending and watching this nice talk that I expect to be nice. I believe it will be important for you if you are interested by PostgreSQL performances, by PostgreSQL observability, and better understand how this bit is working in the background. So please keep watching. And here we are. This is the day for my appointment with the PSI. And so let's go dive in and see what he has to say. Well, I'm Cédric Villemain. I'm involved in PostgreSQL field for maybe nearly 20 years already. I started with full text engine into PostgreSQL. It was very interesting. And then I grew up managing and starting PostgreSQL expertise companies for the last 15 years. Currently, I'm running that Database, and we are a PostgreSQL dedicated company. We are not a software editor. We're providing fully open source support and research program and training center. And so the point of the talk today really is, did you ever ask yourself, how can I manage that? I have a vacuum folder, I have a heavy task to run here right now, but at the same time, this is a production machine, and I will pop up another terminal with a top so I can monitor what I'm doing, and if there is something wrong, I can see that on the top, and then I can act on my vacuum folder or my heavy task. Maybe this is just a huge SQL query which is saturating the IO, whatever. I have one eye on my command, one eye on my monitoring. And then we are looking today, right now, at solutions so you do not have to look at 2 points at the same moment, because we provide you with solutions to be able to observe this monitoring and also to take action, to be active as the pressure on the system is growing. So the agenda is to discuss 3 main top points. First one is PostgreSQL requirement and the processes. And another is about PSI, process state information, what it is, where it's coming from. And then we look shortly into pgPSI, a PostgreSQL extension, and look at some few items in this field for the future. So PostgreSQL processes, there are around 15 processes in PostgreSQL which are interesting to look at, and I classify them in distinct categories. So here we have a distinct group which I define as critical. So here I put, and this is my arbitrary decision, you can do whatever you want on your own, the Postgres process. This is the main mother of PostgreSQL process. So this is very subject to latency, and we want to really protect this process as much as possible. This is critical piece. And then we have other processes which are very important too. Go to vacuum, slot sync workers, WAR receivers, WAR senders, WAR writer, and we have then other kind of activity on the process, on server. You are connecting to PostgreSQL with a regular backend executing SQL command, but also maybe you have some background worker which are started and doing some tasks for you in the background. And then I define another group, which is maintenance process. So auto vacuum workers, background writers, checkpointers, WAR archiver, and summarizer. Summarizer is pretty new, but all of them are important too, and checkpointer is pretty important. But after all, it's not really disturbing the server, except by imposing some performance bottleneck. And then we have auxiliary process like the logger and the fresh new thing from PostgreSQL 18, IO workers, which I was absolutely unsure where to put it yet, because to be honest, I didn't dive into the IO workers really yet. And it, depending on the configuration, it may go into the maintenance, or it may go into the critical, or it may go into the workload process, depending if it's really, I don't know. This is another point to explore, and maybe you will be happy to explore IO workers with PSI later today. Those processes, so we want to categorize them. The purpose here is to be aware there are several kinds of process, and we want to know is to understand how they behave, what they need. And so for PostgreSQL, there are 3 main important topics as usual: CPU, IO, and memory. But what's important to note is that PostgreSQL is a fork process model. It means that when you look at a process on your machine, PID, process ID, this is a single process. There is no thread in PostgreSQL, so it's going to run only a single action at once. There is no parallelism at this point. So for monitoring and observability, it makes things a lot much easier. On CPU, we have workload where it's very compute intensive. Maybe it's because you create an index, but maybe just because you're running analytical workload. In such situation, you want fast and efficient CPU unit. At the opposite, you may be running just transactional workload, whereas a lot of OLTP, very quick transaction for maybe a web application, and then you will probably want a lot of cores and a lot of CPU. More important than just getting a fast CPU unit. Those are distinct workloads. We want to learn them and to understand them and to be able to observe them. There is the I/O, and on the I/O, we have one very important part in PostgreSQL, which is a write-ahead log. You probably heard about it. This is a critical journal. We want it to be always available to write synchronously to the disk. So this is a single process which is writing to the whole stream and as to the whole file. And so we want to ensure that it always got resources. And then we have a lot of other activities which is managed by backend, by I/O workers, or also by background workers, checkpoint workers, and so on, which are going to read and write on indexes and tables, distributing I/O among distinct processes. And last point, we have the memory. In PostgreSQL, this is very simple. We have at the beginning pre-allocated shared memory by PostgreSQL. When it starts, it allocates some shared memory, and we keep using it during its work. Be aware that PostgreSQL supports huge pages, and it's very interesting to activate huge pages, and it's really always a win. And then we have dynamic shared memory allocation. Means that after PostgreSQL started, it may request again more shared memory to manage some workload and to share information between backends, for example. And then last point, we have a per process local memory. So it means that we have distinct kind of access to the memory. Some is shared, some is private. And so we want to know also what distinct processes are doing to PostgreSQL and how they use CPU, I/O, and memory. We need to make a map of that. And this is precisely what we want. We want to be able to observe all processes, understand their workload, and so we can define what kind of resource we need and what are the bottlenecks we want to protect from. And here, start to be interesting to look at the PSI. Precious data information. This is really a way to, instead of notifying too late that things are going bad, you can be informed or you can look at the metrics a very short term to be aware of what is running and what's happening on your server. Okay? And so it allows us to provide very precise and quick reaction and adjusting workload. Maybe you're going to throttle some process, or you're going to pause or kill some queries, or whatever you want to do. It has been introduced 7 years ago by Facebook. And so it's present in the Linux kernel since 2018. Here you have a link with a QR code. There will be other links later. So if you want to get them at the same time, maybe you want to snap and get a QR code as we go through them. So PSI, persistent information, is used by major people, I would say. Facebook, we initiated this project and we have pushed the first pages to the Linux kernel. Is a great and large user pattern of PSI, where they do most of their management apparently with PSI internally, optimizing resource usage and processing. And then there were all the patches provided by Google in order to get not only the metrics, but also event notification, which is a key point because then we can get metrics, and if it goes over some threshold or limits, we can get a notification that something is happening. And they use that to be able to provide on Android a light daemon, which is able to manage the memory on the Android device using the precious data information. Another major user, Cloudflare. Cloudflare has wrote and is proposing a PSI exporter for Prometheus. So it's very convenient and also probably interesting to note that if those major people are using PSI, there is probably an interest to look at it more seriously. Oh, so what's interesting, this is easy. Very often on Linux, you just have to look at files. You send some message to a file or you just cut a file, meaning you're going to read this content, and boom, you get this information. And here we have 3 files, /proc, /precious, /io, or CPU, or memory, that you can look at, and are going to be always the same. 2 lines with sum and full lines with average and totals, okay? And what is interesting is in these 2 lines, we have a sum, and sum means that some process maybe not always the same, but some processes stall. At some point, he stalls on a resource. It means that he has to wait and cannot do anything. He's waiting for I/O, he's waiting for CPU, or he's waiting for memory, depending what procedure you're looking at. And there is a full line. The full line means all the active processes are stalled. So this is a real problem, very probably because your server is not doing anything, just waiting at this point for everyone at the same time. Something probably you want to avoid. And there is the average. So the average is for 10, 60, and 300 seconds to be notified, to be informed about the percentage of time you have been stalled during this period of 10, 60, or 300 seconds. And last point, very interesting, the metrics. Beginning are just average produced by the system, by the kernel. But here you're going to increase and get increased by microseconds on this total, allowing you to provide your own average. You maybe want to provide an average on 20 seconds or in 500 seconds, up to you. You want to detect spikes, bursts, or whatever in the start procedure, it's also available because you have this microsecond metrics, which accumulate every time. You might notice here a point about the average. This is something common. You use it already, maybe in your life on IT. But here with the PSI, this is a little bit distinct because it's not the same average that you used to get for the load. Load average on the system is based on the number of CPU. With PSI, this is just a percentage of time which has been spent waiting for something. And it's completely unrelated with number of CPU, so this is a very easy metric to consider. So there is another interesting point which makes it distinct from load average. In load average, you have a 1 minute window, and you sample each 5 seconds. With PSI, you have a window which is from 500 milliseconds to 10 seconds, and you have a sample each 50 milliseconds. It means that clearly you can have much faster reaction and much fine-tuned observability on your system. One constraint at the moment is that non-root users are limited and they cannot use a window. They must define a window of 2 seconds or a multiple of 2 seconds. This is a barrier in order to not over-consume the kernel on those PSI information. And the last point about average is that on load average, you have an overall load, whatever the process are doing, more or less. This is very fuzzy. Here with PSI, we have a very clear distinction between CPU, I/O, and memory, and some processing which were accounted for CPU with load average are clearly separated between CPU and memory with PSI, for example. So it's much it's more accurate. I believe to get to understand PSI, one thing is to do a demo, but for a webinar, it's not always easy, and there is failure possible. So I just prepare you a pseudo demo, which is this slide where we have 2 tasks, A and B, starting to run on a server. And then after 2 seconds, they are still running, and it's very nice because they are just running without being stalled at all. But then, at the 2 seconds, test A starts to be stalled and is waiting on something, depending what you are looking at. Maybe you're looking at CPU or I/O. Let's say we are waiting on I/O for 1 second. And so this information about this process is going to change the average and change the total. So we can see the total. And here I put seconds instead of microseconds because it's easier to read. So you can see that we are waiting for 33%, and we already accumulated 1 second of stall time. And then it keeps on running, and the second task, task B, starts to be stalled also. So at this point in time, we have some counter which is going to grow because we still have some task which is stalled, but also at the same time, all tasks are stalled. So the full line starts to increase. And so we have a very clear information. If it's just one single process, it's stalled, maybe it's not so critical. But if all are stalled, there is probably something going on. Later, the task A get back to work, and task B remains stalled. And so you see that the counter for the thumb will be accounting the time spent by task A then by task B being stalled for something. And you see on the bottom that the average and the total have been moving. And as we go over 10 seconds, we get 60% wait time on some process, and we get 40% wait time full on all processing, 4 seconds and 6 seconds. So this is clearly what we want to have, and a very tiny level with PSI getting those metrics, and even more getting some feedback when it goes over some threshold. So here we have that. Today, with PSI, we're able to observe very precisely how the system is behaving and how the pressure is growing. We have that at microsecond counters, and we have very frequent samples of 50 milliseconds. This is superior to any previous solution to be able to monitor and to observe a Linux machine. The other big angle of PSI is this event notification. Clearly, here we are able to define triggers, meaning that we're going to say to the kernel, I am interested to look at the I/O or memory or both of them, and I want to be informed if some task is logged on I/O for that many seconds over that many, for that many milliseconds over that window of 2, 4 seconds or 6 seconds. So let's take an example here where I register a trigger, which is to be fired once we have accumulated more than 250 milliseconds of start time on I/O over 4 seconds. Okay, so we just send this text message to the file, not with a Linux machine. You need to have a code for that. And if we go over this threshold, we get an event. What we do is that then we define the trigger, we poll on the resource on the ProcPressure I/O, and if there is something to be signaled, kernel will send us a PRE signal, which let us know, oh, something with priority and interest is happening on a pressure I/O, meaning your trigger has fired. You are under pressure. And you see this is very low level API. You can use it to monitor, but if you want to do polling, you probably want to use existing tooling or what your own tooling, or you do that with your own code. Another point at the side of the PSI is that PSI is not only available for the global system, it's available for each C group on the machine. It means that for each C group, we're able to get the average load on CPU, I/O, and memory, and be able to compare process with other processes in the same C group. For example, in C group, if we say all tasks are locked, this is all tasks from this C group, not from the system. Be aware that C group are used everywhere today. This is base for systemd, which is running Linux boxes worldwide. And this is used by Docker, this is used by Kubernetes, this is used by mostly everything is running on C group. So here with PSI, we have a very fine information even in your container application. So what it brings so far, this PSI is a more granular metrics. It's an easy to use user-learned interface to observe and adjust the workload and to get kernel event notification. This is very convenient. We have external tooling as, for example, this PSI exporter from Coolfair, and there are many other tools available in the monitoring field. But for PostgreSQL, I wanted to get something available for us DBA to be able to operate and to get to know more easily our workload and what's happening on the PostgreSQL instance. So I bring PSI to PostgreSQL with pgPSI. So this is very similar to what we saw. We're going to register triggers with a C group. For example, here I'm listening to look at the workload C group, and I want to control the resource I/O. And if some task is stalled for 50 milliseconds over the last 2 seconds, I want to be informed. And here you see the file path, which is shortened, but it's a file path on the system that you can also go and look and do a cat on it, so you get information directly from I/O pressure on this workload C group. Once you did that, you have 2 solutions with pgPSI. One way is to just use interactive polling. So you just start your session, you register triggers, and then you execute pgPSI poll. And then if events are fired, you get a notification informing you, for example, here that we have to wait 50 milliseconds for 50 milliseconds over the last 2 seconds, and we got some I/O pressure in the C group workload. The other way to use it is to use it as a background worker, meaning that you are going to run this background full or this huge task, and you want it to be suspended or canceled as soon as the workload on the machine is going too high. So one way is to just register triggers which are accurate. Maybe it's going to be a sum of I/O, memory, CPU, and you want to control these 10 kind of things. And if they fire one or the other, then it's going to suspend the task which is running on. This background worker is dedicated to my session. It's not working for the processes, just for my session that I started, where I started the background worker. Then I start a vacuum full, and after some time, because I'm running a PG benchmark at the same time, vacuum full is cancelled by my background worker, and so the PG benchmark can keep running. If you're interested by the PGPSI project, I invite you to go and look at the website. So it's hosted on Kohlberg. Kohlberg is a non-profit organization based in Germany, which is providing a lot of open source support. The project itself is under PostgreSQL license, and so we will be very happy to have you join our community and be involved in this project. Feature of PSI is on two angles. We have first an ongoing discussion on the kernel side. We want to get shorter window for PSI. As I mentioned, when you're not root, you have 2 seconds only. You can do 2, 4, 6 seconds. But often we want to react more promptly after maybe 500 milliseconds or 1 second. This is very better to be able to adjust the workload sooner. Okay. The other point is that there is ongoing discussion to get PSI support in eBPF. So I'm a little bit excited here because eBPF is a sandbox engine inside the Linux kernel, which allows you to run efficient program to manage what's going on in and out. And so it's a good place to insert things and to change what's happening. And so getting the PSI API inside eBPF allows us to provide sandboxed software to do memory management in place of, for example, the OOM killer from Linux. Another angle is the feature of PGPSI, and here I have two things I want to do. First thing is to provide a pluggable trigger action. So the point is that monitoring and taking decision into this field is very complex. It's hard to get one algorithm for everything. We tried for several decades and it's always complex. So here I want to provide just the basic, always interesting features like cancel this query, but also allowing you to implement your own logic and define your own action on triggers. So PGPSI purpose is to provide you an interface so you can add and implement your own logic based on your own workload. The other angle is to provide stat interface for PGPSI, thus providing an option to export metrics from the C group we define here, and to observe, assess, and adjust our workload also on PostgreSQL itself, but also by exporting them for any monitoring system. As we saw before, you can also just use a PSC exporter from Prometheus. PGPSI is not very important for that purpose, but when you're a DBA, you like to be able to connect to PostgreSQL and get to know about the system as you're connected under SQL, and not having to go to SSH and execute top command or whatever. This is what it brings. With the stat, we expect to be able to know how many times a trigger has been fired, for example, or whatever other information is interesting. I wanted to do a small demo, but honestly, it's not very convenient. So instead, I just get 2 screenshots just to make a difference between what we had and what we can have today. The first thing here is the top. So here I'm running a PG benchmark. It's loading my machine. And you see there is commit and there is updates and there is IO workers. We can see them and checkpointer, background writer. All of them are visible on the top. And you have interesting information. You have a load average. All of that is nice. Okay. What I'm bringing here with PGPSI is more vision where you can know for PostgreSQL itself where it's happening and what's happening. So here it's much easier for me at least to see, okay, on my workload group, and my workload group are my background worker and my SQL queries. As I'm running my PG benchmark, I see there is a lot of stall time. I'm waiting nearly 2 seconds, over 2 seconds. So I am very stalled on IO and on CPU, as is visible on the top 2 first row. And I can also see that there were some stall time on the word writer, 1 millisecond, which is not good. We know that already. Oh, and apparently the background writer and the word writer were active on CPU at the bottom. So this is much more detailed. I expect this kind of information will allow us really to understand better how PostgreSQL processing are behaving, what resources they need, and to ensure that we can have smoother production workload. So it has been a quick introduction to this topic. I hope you like it. And then I have this slide with some, I believe, interesting links to look at the work ongoing for PSI into BPF, which is the first link. The original PSI documentation from Facebook microsite, which is very easy and nice to read, a good overview and go into the technical details of what they did and why, because they changed the strategy over time. And then the official kernel documentation and the properties exporter from Cloudflare. So here we are. I hope you like this talk, and I'm really happy now to listen to your question or comments and to feedback to you.
Wow, thank you very much, Cédric. That's a really interesting topic. Something that I don't know much about. I'd love to go and find out a lot more about that. I'll be following your links and checking that out. Don't forget to, if you want to ask Cédric some questions about some of this work, he's in the Discord channel and available to talk about it. Also, don't forget to complete the survey. So the title of the talk for that one is Resource Control Admission. I have a date with my PSI. Do the survey and you might win some socks. Supplies are limited, but you'll probably get some. All right. So for our next talk, we have Elly. Elly organizes the Malmö Postgres user group, and she's involved in a lot of different conferences like this one, but many others. And she is going to be talking about user groups and bringing people together.
Hello, I'm Ellyne and I work at marketing at dbtune. My talk is titled Setting Max Connection, Building Postgres User Groups that Bring People Together. I'm really excited to be here at Posette today. I'll be sharing some practical advice on how to create successful Postgres meetups. If you're interested in fostering thriving Postgres communities and creating interactive and fun small and large scale events, this talk is for you. Now let's get started. We all know that setting the right max connection is crucial for a healthy and high-performing database. But what about the max connection of our community? Today, I want to explore how we can optimize those connections by building vibrant and effective Postgres user groups. Just as we tune our databases, we can also tune our communities for engagement, growth, and resilience. So let's discuss the parameters that make a Postgres user group thrive and how you can set them for maximum impact. And I'll also be answering your questions on Discord along the way. So here's a quick agenda on what we'll cover today. First, I'll talk about myself and a little bit about dbtune, where I work. We'll talk about community, what is community, the Postgres community, and the vital role of user groups. I'll also walk you through how we built the Malmö Postgres user group, or the MPOG. And finally, I'll provide you with some actionable and practical tips on how you can create your own start your own successful Postgres user group. So I'm Elly. Originally, I'm from Singapore, but right now I live in Malmö, Sweden. My journey has been a combination of technology, communications, entrepreneurship, and community building. I got my first job at ZDNet, an enterprise technology publication, and that was how I was first exposed to the world of technology. Later on, I moved into public relations, marketing, and communications for technology companies. I became really interested. And in 2021, during the COVID pandemic, I got a scholarship to study my master's in entrepreneurship and innovation from Lund University. And that's when I moved to Sweden. As an immigrant living in Sweden, I faced the challenge of forming my own community from scratch. This experience taught me the importance of creating meaningful connections and fostering a sense of belonging, especially in a new environment. I also started working for the school's communications and alumni relations, where I further learned about community building. And in 2022, I joined dbtune, where I worked in marketing. And this was also the year I learned more about Postgres, became more deeply involved with it and the ecosystem. Over the last 1.5 years, I got the privilege of contributing to many Postgres events and activities. sponsoring events, running booths at conferences, and being an organizer at the Malmo Postgres user group. We just got our new logo couple of months ago. It's retro themed with the turning torso and the Postgres, the Sloanic logo, and I'm really excited about it. So all these experiences gave me a deeper appreciation for the power of community, and it's been very rewarding to see how collaboration drives innovation in the Postgres space. Here's a quick introduction of my company, dbtune. We are an AI-powered optimizer, tuning Postgres database configurations for top performance. Our technology is adaptive, regardless of workload, machine size, and environment, whether it's on cloud or on-prem. We specialize in Postgres performance, helping companies optimize, scale, and reduce costs, and get the most out of their databases. We just launched V2 of our product, where we have continuous monitoring, self-hosted deployment, tracking your configuration history, and always-on agent, and more. We are one of the top 20 sponsors of Postgres conferences, and we are also very deeply involved in the Postgres community, sharing our insights, and supporting user groups like Wolk. So if you'd like to learn more about what we do, you can scan the QR code here and visit our website. Let's talk about what a community is and how it's formed. At its core, a community is a group of people who share common interests, values, and goals. Communities have existed for centuries, starting with early tribes that shared resources to survive, and then evolving through agricultural societies, cities, and now in digital spaces. They have always been very vital to human culture, helping people to connect and share knowledge and support one another. Communities are formed when people with a shared interest interact, whether it's online or in person, and they establish a sense of trust and mutual support. And over time, they can grow into more structured groups with events, resources, and a collective mission. This is how we see modern communities, especially in Postgres. Now, great ideas don't just happen in isolation. They emerge when people come together to share knowledge and solve problems. In The Wisdom of Crowds by James Surowiecki, it shows that groups make better decisions than individuals, especially when they bring diverse perspectives. If you look at this visual, it shows the evolution of decision-making from one person to a diverse group. If you have a single expert, his or her knowledge is valuable, but it's limited by personal bias and a narrow view. With a group of experts, they bring some depth, but their perspectives alone cannot always drive innovation, and they are constrained by groupthink. And then we get to the crowd. This is called this is where you can get a diverse range of ideas, experience, and perspectives. In a tech group like Postgres, collaboration across this leads to better problem solving, innovative solution, and accurate decision making. The arrow on the right side also shows that as we move outwards, there's better decision making and, most importantly, enhanced innovation. That's why collaboration is so vital in Postgres. By drawing on the collective intelligence of everyone, we can fuel breakthroughs that drive the future of Postgres. And there's nowhere this phenomenon can be seen more evidently than in software development. Historically, software development was in closed source environment. The code is tightly controlled, limited contributors, innovation is slow, everything is confined to a few voices, and this really slowed down development and kept software isolated. But with open source software, everything changed. Open source can let anyone, anywhere to contribute to the software, and this increased the pace of innovation. And instead of a few contributors, there's now a global community of developers, just like the diverse crowd we talked about earlier. And now they can collaborate to create faster solutions. And Postgres is a prime example of this shift. If it was just constrained by a few contributors, it would face the same issues. But because it is open source, the project is now flourishing thanks to everyone all over the world working together to push it forward. Why is community so important to Postgres? Because it is not just a database, it is made by everyone. At the heart of the Postgres community, there's collaboration, transparency, and shared learning. It all started with a small group of developers and database enthusiasts working together to improve open source technology. But over time, this grew into a worldwide ecosystem with contributors of all backgrounds, developers, DBAs, users, advocates, coming together to push Postgres forward. And today, the mission is to advance Postgres to support its continuous growth and innovation. Postgres' strength doesn't come from its technology, it comes from its people. And a strong and engaged community is what drives innovation, improves database, and ensures Postgres continues to evolve for the future. This is what makes us unique. We are a movement powered by collaboration. What's a Postgres user group? This is a community of enthusiasts in a city who come together to share knowledge, discuss best practices, and collaborate on projects. They are very important for fostering learning, innovation, and networking in the ecosystem. Some statistics. Today, there are 197 Postgres user groups worldwide, with over 97,000 members on Meetup alone. These user groups represent recognized and unrecognized user groups. And as of today, there are 67 officially recognized Postgres user groups, which shows our reach and influence in supporting the database community. And where did they meet? This map was taken from Claire Giordano's presentation at PGConf in EU in Athens last year. As you can see, there are many groups in the US and Europe alone, highlighting the global reach of the community. Some of the most active Postgres user groups are in the US, Germany, France, Spain, and Sweden, where groups regularly meet for talks, workshops, and organize meetups. And this is why the community is so special. It's not just about database. It's about how passionate and welcoming and diverse these individuals are around the world. This was taken from Claire Giordano's Talking Postgres podcast, where she interviewed Daniel Gustafsson. And he talked about his experience at his first conference and the essence of the community's welcoming spirit. Many attendees arrive as strangers, but leave feeling like they're part of a supportive network. And this is from a blog by Ryan Booth, a Postgres advocate at RateGate. In his blog in 2022, he observed that in the Postgres community, there are many opportunities to build upon its strong foundation. So what does it mean to be a recognized Postgres user group? First, your group needs to be officially listed on the Postgres website, and this makes it easier for new members to find you. Recognition comes from the Postgres Global Development Group, and beyond visibility, it gives you the resources, potential, sponsorship, and the ability to collaborate with other user groups. Before submitting for recognition, it's important to follow the user group guidelines over here. So first, your group needs to be focused on Postgres and not just a general database or tech group. It also needs to be public and inclusive, no NDA, no restricted access. You have to ensure a safe space. You should also follow a code of conduct that promotes respect and diversity. And then you have to have one event every 2 years, active engagement. And if your group receives sponsorship, you need to be transparent about it. For the full details, you can check out the Postgres user group policy. How do you get it recognized? So we talked about this in the step one. We already talked about it in a previous slide. Like follow the guidelines. The next step is to actually host an event and create like a portal where that publishes your event. And when you do that, you don't forget to host your event. Don't forget to take pictures and videos. And this shows to show proof that you have already had your event. This ensures that your group is contributing to the Postgres community. And finally, once you have all these, submit all the details to user group at postgres.org for approval. You can find the email here on this slide. Now, we formed the Mamo Postgres user group last year. You can scan the QR code to join our user group. In a span of 5 months, we already have more than 120 members in our meetup, and we already had 6 meetups. Malmö is the 3rd biggest city in Sweden. We saw an opportunity to develop this user group in Malmö, as there was already one in Stockholm and several technology groups here. A big part of growing any user group is bringing great content and having a diverse group of speakers. So we're always looking out for speakers and to join us to keep the community growing. If you are passing through Copenhagen or Malmö or somewhere in the Øresund region and have some time to come by, please don't hesitate to reach out to us. The first step was to find fellow organizers. So we managed to find myself, Luigi Nadi, Daniel Gustafsson, and Dennis Rilorin to join us and build a community. Next, we had to find a partner, and we found Full Cafe. This is a local organization, local event organization in Malmö that works with technology groups for meetups. This gives, by working with them, we get credibility and a location for our events. And I highly recommend this approach, partnering with local tech spaces or even existing software-related events to give your group a strong foundation. Finally, we created a meetup page with the Postgres logo and the description of who we are. After securing a space and partners, we had to decide on topics. We wanted to be sure we were picking something relevant for the community. So our very first talk, which Daniel Gustafsson volunteered to give, was on the Postgres project, creating the most advanced database. It was basically an introduction to Postgres, its community, and the database. Next, we had to promote the event to the local community. So we used social media, word of mouth, and our personal networks to spread the network and get event attendees excited about it. The benefit of doing it with a partner was the double promotion on both sides. So Full Cafe also sent out newsletters promoting the event. And our first event was a huge success with more than 45 attendees. And this is actually a lot for a relatively small city like Malmö. Since then, we've had like 5 more events, and the interest continues to be quite high, with about an average of about 20 to 30 people showing up each time. And over time, as your group matures, you can gradually become more independent. But partnerships will always be the collaboration, and collaboration will always be crucial to success. So now I want to give you a 5-step process on the things you need to think about when you organize events. So let's assume you already found fellow organizers and formed the group. And when organizing the Postgres user group, one of the first steps is to create an event page or like a landing page for attendees. You should have a space where you can consolidate everyone and keep them updated for upcoming events. So most people use Meetup and LinkedIn groups. Others you can consider are Eventbrite, where you can publish events, track attendance, and manage ticketing in one place. Facebook events, a little personal, but at least you can share it with some of your friends to show them where you are headed to. Slack and Discord, this has real-time engagement and communication, and you can create channels and an interactive space as well. And also Telegram, where a lot of people are using right now, including for several Postgres events, where you can keep attendees updated on events and Postgres news. So in our case, we could find Full Cafe as a partner, but sometimes you can partner with companies that have already event spaces who are looking to support the community. So it could be co-working spaces, tech hubs, even local companies in the Postgres ecosystem. So these partnerships will benefit both sides. The hosting organization gains visibility, and you get the space and resources you need. And you should also look for partners that share your goals of fostering learning and networking. The next step would be the content and speaker planning. This is what keeps your community engaged and coming for more. So Postgres covers a wide range of areas, and it's important to focus on topics that resonate with your audience. You can do this by doing a search online, looking at forums, talking to your attendees, asking them what they like, whether it's performance tuning, high availability, new features, new products. Next, you should engage the speakers, like aim for a mix of voices, experienced people, new perspectives, diverse backgrounds, and always encourage your speaker to prepare, because to rehearse and structure your talks in an engaging way. And lastly, the format and structure. Traditional talks, panels, live demos, and even networking sessions to match the format to your audience and your goals. To make sure the event runs smoothly, this is the next step. Think about event logistics. For the venue, choosing the right space is important. You should think about accessibility, size, location, as well as essentials like Wi-Fi, comfortable seating, and AV equipment. But if you decide to do a virtual one, use platforms like Zoom or Google Meet, something that is stable to help create a good experience and make sure that it's easy to use for everyone as well. You can use Slido and Mentimeter for like polls, Q&A, and discussions, and always make sure you record the session so you can make the content accessible for those who can't attend live. And lastly, there's food and socializing after the whole meetup. Nothing beats pizza, drinks, and networking. Also take their dietary preference into consideration. So make sure you always have a vegetarian or a vegan option. And lastly, it's also the meetup is not just about the content, and it's also about connection. Make sure no one gets left out. Try to introduce people and always talk to people who might be alone, standing alone. And so organizing a meetup is really exciting, but sometimes there are challenges. So one of it is low attendance. People might RSVP, but they don't show up. Then there's speaker cancellation, a last minute dropout. And even when people attend, they might, if you do not keep them engaged, they might get bored, and then they will lose interest and they will stop coming for your meetup. And also sponsorship struggles or like partnership struggles. So these are common issues, but we have come up with some solutions for this and some ideas that you can explore. So for low attendance, you can send teaser videos and messages, or you can implement a waitlist system for people who always RSVP and don't show up. You can put them at the bottom of the waitlist. And you can also give perks to consistent attendees, such as content or like swags. And if a speaker doesn't show up, some formats you can explore are like show and tell lightning talk. So this is where people go on stage. Not the stage, like the front of the room to talk for 3 to 5 minutes on a Postgres tip or tool or lesson. Or you can have community spotlight where users talk about their real world experiences and then some solutions. You can also keep a virtual speaker as a backup to make sure people are not bored. You can have some ideas you can explore as a community fix live problem solving. This is when somebody goes up and says, I have this problem, and then this is how, and then everyone discusses how to resolve it together. Or you can put them in breakout discussions so that in smaller groups, people might be more open and they feel safer to share, and they can have deeper conversations. Or speed networking. Making people talk in for like 5 minutes or 10 minutes and then moving on to the next one. And lastly, for partners, if you have partnerships struggle, there's you can offer logo visibility in exchange for venue space, or partner with universities or research institutions. They usually have really nice spaces, or vendors as well. So I would also love to hear from you guys after your meetups, like what have you tried, and whenever there are unexpected challenges, and what works best. So here's a case study. At one of our sessions, we faced a last minute dropout. The speaker canceled 10 minutes before the event, and we only found out when we got to the event space, because he got sick. It was completely unexpected, and it was no one's fault. But so instead of canceling or scrambling, which is understandably quite stressful, we simply asked the audience if anyone wanted to present. And to our surprise, some people actually stepped up and said that, oh, I can talk about this and that, or I already have a presentation on hand. And one attendee actually shared that he knew a lot about the topic, which was Kubernetes, and he took the lead in answering the questions, and it turned out to be really interactive. Here's feedback from one of the attendees, and who eventually gave a talk at our user group. He said that he was actually preparing for a Kubernetes presentation the following week. And because of this discussion, he learned some new stuff and he could incorporate them into his presentation. Yeah, so this moment reinforced something important for us. Community-driven events don't just rely on a speaker. Sometimes the best conversations happen when we let the group guide the discussion. Okay, and how do you know the event was successful? This is what we'll talk about in step 4. So you look at attendance, how many people registered versus how many showed up. Engagement, were they actively participating in Q&A, discussions, the polls, post-event feedback? One thing I like to do is go to them during the networking session, ask them how they found it, do a quick verbal survey, and ask them what they like and didn't like, what did they learn, what did they want to hear next time, and continuous improvement. Make some adjustment based on past events, and what didn't go well this event, we should avoid in the next event. Another way to look at this is, which I like, it's called the Kirkpatrick 4 levels of evaluation, where you look at the reaction. Did the attendees enjoy the event in learning? Did they gain new knowledge, behavior? Are they applying what they learned? And the results, what's the long-term impact? Are they going to contribute to Postgres in the future? So ultimately, measuring success helps us continuously improve and ensure each event is more valuable than the last. And finally, the work doesn't stop when people leave the door. So to maintain momentum, follow up with them by emails and social media, share the recordings, slides, and on platforms like Slack or Meetup or Discord. A single event isn't enough to build a community, so you need to think long term. And this means you must plan regular meetups like every 2 months or 3 months, or like send out newsletters to keep them engaged or encourage ongoing discussions. So the goal is to make a community a lasting and valuable space for learning and collaboration. Finally, I spoke to some experienced Postgres organizers on how we can enhance the planning of these user groups. So Andreas Scherbaum from the Berlin meetup group, he talked about the waiting list, which I suggested earlier, like move no-shows to the end of the waiting list. And this actually improved his attendance from 30% to 70%. He also takes the lead on taking pictures, asking speakers to share the slides, and writing a blog on it. Hari Kiran from the Hyderabad Postgres group, he says he engages experts directly or like in local tech groups and LinkedIn. He also gives speakers the flexibility to decide on topics. And Andrea Cucinello from the Barcelona Postgres user group, he talks about expanding the meetups by connecting with related communities like the Kubernetes or the cloud native one for cross promotion. So if I could summarize 3 takeaways for you. First, work with a partner to spread and the right platform to spread the word of your user group. The right partner with similar goals, such as Full Cafe, can open the right doors for you and provide you with marketing and logistics support. Use the platforms to announce your events, keep the momentum going. Next, implement effective attendance strategies, adjust for no-shows, manage wait lists, keep an eye on registrations, share the materials to add value, and keep the interest alive long after the event is over, and plan for sustainable growth. Build a foundation with recurring events, maintain communications through newsletters, regular updates, foster a welcoming community environment that encourages continuous learning, collaboration, and the sharing of knowledge. So by focusing on these strategies, you can build a thriving and engaged community that continues to grow and thrive in years to come. Lastly, I want to leave you with this thought. Postgres wouldn't be where it is today without its community. And every great event, great contributor, and innovation starts with people. So I know that organizing a user group sounds like a lot of work, but in my experience, it's actually really fun and rewarding. And I got to meet many interesting people, learn more about new Postgres topics, and connect with amazing speakers. And it's also about giving back, helping others while growing your own skills and network. So I encourage you to think about how you can get involved. How will you contribute? If your city doesn't have a Postgres group, could you start one? If you have attended events before, how will you improve them? Or maybe you can volunteer to organize, speak at an event, or bring a new idea to your local Postgres group. Every small contribution makes a big impact. And at the end of the day, it's not just about running events. It's about being part of something bigger, a movement. The more you share, and the stronger Postgres becomes. Thank you so much for your time and attention today. I hope you found the session useful and you are feeling inspired to create your own Postgres event or contribute to the Postgres community. See you.
Thank you, Ellie. This has been a great talk. Building communities is hard work. I'm co-hosting the Warsaw user group, and I also did the BSD user group here in Warsaw. And we actually used that cross promotion between the 2 events to gather more people, and that worked very well. So be sure to go on the survey page, fill out the survey for setting max connections, building PostgreSQL user groups that bring people together, and help Ellie improve her talks and figure out how well she did, or any good or bad feedback that you might have. Now with this, if you have any questions, people are in the hallway track. Go to Discord. All of the speakers were showing up today and actively participating in discussions. So don't waste that opportunity to ask live questions. And I would like to welcome our next speaker, Rahila Syed, who has like over 12 years of experience as a PostgreSQL developer across a range of features. But most importantly, today she will be talking about designing a monitoring feature in PostgreSQL, which I find very interesting as it's something that I'm actively pursuing for Citus. So I'm looking forward to this talk.
Hi everyone, welcome to Posette conference. I'm Rahila Syed. I work as a senior software engineer in Microsoft. Today I will be talking to you about monitoring in Postgres, and also will be explaining a design of monitoring feature in Postgres. This talk will be useful for developers and administrators who are looking to learn more about monitoring in Postgres. Hi, so let's get started. Let's look into monitoring in PostgreSQL. Let's look at the agenda. First, we'll start by describing types of monitoring features in Postgres. Followed by that, I will explain a bit about memory contexts and DSAs and DSMs. After that, we'll look into the design of a specific monitoring feature. So what are cumulative statistics? Cumulative statistics is a subsystem in Postgres which allows you to collect and report information about the server. In this, each process that's doing any activity publishes the counters and statistics into its local memory. It copies it into its local memory, and at a point in time when it is idle, it goes ahead and copies the counters and statistics to the shared memory. Once these statistics are copied into the shared memory, a client which is trying to access these statistics can read the statistics from shared memory and display. Such a client usually calls a function or a view using an SQL command to monitor these statistics. These functions are prefixed with pg_stat. The examples are listed on the screen. pgstat all tables. This is a view that gives you information about accesses to the tables, how many times a table has been inserted, deleted, updated. pgstat wall gives you information about wall activity, and there are many more like these. These statistics are stored into a file after a server is shut down, except in the case of a crash, in which case it is not saved into the file. So when a server starts up, it can read from the file, and it does not have to start from the scratch. The statistics which are fixed size, for instance, wall writer statistics or checkpointer statistics, are stored in the fixed shared memory. While the statistics that are variable, for instance, the number of tables can vary in a particular server. So these kind of statistics, table statistics, are stored in dynamic shared memory. Now let's look at what are dynamic statistics. Dynamic statistics are point-in-time statistics. They give the current real-time view of what the server is doing. For instance, pgstat activity gives you an idea about which transaction is being run by a Postgres process or a backend. pgstat progress vacuum tells you how far your vacuum has progressed. All these counters are updated instantly in the shared memory if the GUC track activities is set on. These statistics are stored in a structure called PG backend status in shared memory. So now let's look at the components of a monitoring feature. The first one would be a monitoring function. This is essentially an SQL function which is backed by a C implementation, usually in Postgres, which is responsible for querying the server for statistics. This can also be turned into a view for more concise output. The next component is shared memory structure to store the statistics. So this can be either main shared memory, which is fixed size, or dynamic shared memory, which can be variable size. The third component here would be Postgres process, which updates the statistics counters. So any Postgres process that is doing any activity updates the statistics counters either periodically and at a point when it is idle, it goes ahead and updates the counters to the shared memory, or it can do it instantly, as in case of dynamic statistics, or there can be a third way to upload these statistics that would be on demand. Like whenever a process is queried for stats, then only it will upload its statistics in the shared memory. The fourth component here is synchronization between processes. So when there are multiple processes trying to access the shared memory, we use LW locks or spin locks to guarantee mutual exclusion of the memory being accessed. The other type of synchronization is signaling between the processes. So we use latches or condition variables to signal between these processes. So now let's dive into a specific monitoring feature, which is memory context monitoring. And for that, let's first look into what memory contexts are. So memory contexts are a way to group memory allocation in PostgreSQL. We group these allocations so that they can be deleted all at once. So it becomes managing memory easier. These memory contexts are arranged in a hierarchy. A memory context can have n number of children, and it is usually a child of another memory context. These memory contexts can be created on the fly by backend. Whenever it's trying to allocate memory, the backend will first create a memory context, and that allocation will then be associated with the memory context. Each memory context is organized in a tree-like structure. When a parent context is deleted or reset, all the children are also deleted. This makes reclaiming memory easier. If you imagine like a tree-like structure, the root of this tree will be the top memory context. And this top memory context is created at the server start. The top memory context essentially is never deleted. It only is deleted when the server stops. And allocating a memory in a top memory context means that essentially you're doing a malloc. So the levels of this memory context trees are numbered starting 1. So the top memory context is at level 1. This is this is something that is used in the monitoring of these contexts. So in the monitoring of the context, the level 1 is the top memory context, and then we go further down. Each of these memory contexts contain the stats about their own memory consumption. Like it will store how many bytes of memory has been allocated, how many bytes of memory is freed. All of that information is contained in these statistics, in these contexts. So when these memory context stats are displayed, it gives you a good picture of the memory consumption of a process. So why there is a need of memory context monitoring feature? There already exist a couple of features that allow you to monitor memory used by these contexts. They essentially list down all these memory contexts and the stats associated with them. The first one here on the screen, which is PG get backend memory context, it allows you to get the memory consumption information, which you can get by querying memory context statistics for a local backend. So it can't query the stats for any other process, and thus it is restricted to only the client backends. The second one is PG log backend memory context. This one essentially allows you to log the memory context statistics in your server logs. The disadvantage of this one is that you have to have an access to the server logs to be able to read these files. And also, the server logs need to be scanned for relevant information, because server logs can have all the other forms of logs and error messages. So you have to scan through the logs to get the relevant memory context stats information. So hence, there's a need to have a function which will allow you to instantly query the statistics from any process, not just the local backend, and show it to you on the console, on the PSQL console you're using to query the stats. Let's look at the components used in designing such a monitoring function. The first component is dynamic shared memory, which is DSM. Since I mentioned that a backend can create any number of memory contexts, we need a memory that can expand. The main shared memory in Postgres is a fixed size chunk, which is created at the start of the server, and it can't be expanded. So we need something like a dynamic shared memory, which is a framework that creates, manages, and shares memory segments between the two processes. You can do that at runtime when a server has already started, and it is used in features like parallel query and for other IPC needs. DSMs. So this is more about the APIs used in the DSMs. Essentially, if two coordinating backends want to share information between themselves, what they can do is one of the backend can go ahead and create a DSM segment using DSM_create. This will allocate memory for the DSM segment, and it will also map that DSM segment to processes local memory. The DSM_create returns a descriptor, which can then be passed to the DSM segment handle to obtain a handle to the DSM segment. This handle can be shared between the processes trying to share information. So when this handle is shared by another process, it can attach to that DSM segment using DSM_attach and pass in the handle. This results in mapping this segment to any process's local address space. Once a segment is mapped to the address space, one can use APIs like DSM segment address to get to the actual local pointer for that DSM segment. Once you've converted the pointer into a local pointer, then you can access this DSM segment for writing and reading of information. DSM_detach is used to detach from the segment, and once all the backends and all the processes have detached, a segment is destroyed. Now let's look at something called a DSA. It is nothing but an abstraction on the top of the DSM. It handles creating, attaching, and detaching to DSM segments internally, and it provides an interface for the user to create smaller objects and pointers within the DSM segment memory chunk. These pointers are pseudo pointers. Unlike regular heap, they are not real pointers, and they can be converted back to backend local pointers. Once a backend has the pseudo pointer, it can convert it to a local pointer to be able to actually access the memory. Let's look at a few DSA APIs. Here we have DSA create, DSA get handle, DSA attach, DSA pin. So DSA create is used to create the DSA segment. DSA get handle is used to get the handle to the DSA area, which can be shared between the backends. DSA attach is used by a process to attach to a particular DSA and then eventually start sharing. DSA pin is used to keep the DSA alive even if all the backends have detached from it. Here I'm using the term backends and processes interchangeably. DSA pin mapping. This is used to keep the mapping of the DSA into the local process until the end of the session, until the process is exited. DSA underscore allocate is used to allocate smaller chunks of memory, smaller data types, and smaller objects within the larger DSM segments. DSA free is used to free the memory which is allocated previously so that it can be reused. DSA underscore unpin is used when we want to destroy the DSA after all the backends have detached from it. So now let's look at such a monitoring function. This monitoring function essentially, when it wants to query memory consumption of a particular process, it will send a signal to that process and it will wait for the response from that process after it has published the stats. Then it goes ahead and reads those stats and gives the output to the user. This monitoring function is an SQL function with a C interface. It is implemented. These are some of the implementation details which you see. We add an entry for the function in pg_proc.dat, and we include that header in the implementation file where the C definition exists. Okay. So now let's look at the shared memory structure of such a monitoring function. If you see on the left, there is a static shared memory which contains an array of structures. These structures are all indexed by a proc number, and the max size of this array is the max number of processes that you can start in Postgres. Each of these array elements contain a process-specific variables. It contains metadata about the actual stats which we store in the dynamic shared memory. It contains LW logs, condition variables. So LW logs can be used to govern access to the shared memory, the DSA stats. The condition variable can be used by a process to signal all the clients that are waiting for the memory to be copied by a particular process. It also contains a DSA pointer. This DSA pointer is basically something that points to the dynamic shared memory area and the memory allocated in that area for this particular process. And this memory actually contains the statistics dumped by this process. And these can be variable sized. Now let's look at the overall architecture. So here, essentially, these are on-demand statistics. A client backend which is wanting to query memory consumption statistics of a process sends a signal to that process. That process then handles the signal in the form of an interrupt handler. The interrupt handler actually goes ahead and sets a bit in the process, which is a global flag. This tells the process that this signal needs to be processed at some point when it is safe to do it. So then the processing of the interrupt happens whenever it is safe in the process to call the processing logic. The processing logic essentially just copies the statistics to shared memory. After copying the statistics, it signals on the condition variable for that particular process to wake up the client which is waiting for the statistics. The client is woken up, and then the client goes ahead and reads the latest statistics. As explained earlier, the synchronization happens using LW logs and condition variables. LW logs are acquired before reading or writing such statistics to the dynamic shared memory. PostgreSQL client waits on the queried process's condition variable to receive the latest statistics, and the same condition variable is signaled by the publishing process when it's done publishing the statistics. So let's briefly look into why dynamic and not static shared memory. So dynamic shared memory is expandable. It can be allocated while the server is running, and also if we use dynamic shared memory, we can have a dedicated space for each process without pre-allocating large chunks of memory, which we would have had to do in case of static shared memory. Static shared memory is fixed size and it is allocated at the server start. So that's why we need to know the size in advance, which is not possible in case of memory contexts stats. If you imagine something like a fixed size chunk, like a queue, for instance, which would have a fixed size, then when the queue becomes full, a publishing process will have to wait for the client to read the stats before publishing new stats. So that would result in wait times and delays at the publishing process. So let's see why DSM versus DSA and which one was used in this particular feature. Since the DSA supports allocation of smaller objects and different data types, DSAs was used instead of raw chunk of memory that DSM provides. It provides flexibility to free the memory whenever it's not used. Let's look into file handling versus aggregating statistics. So essentially, as I explained, the memory context can grow to a very large value, and we can't store everything, all the context in a RAM. Probably we don't want to use so much of RAM for this particular feature. So we need to limit the memory footprint of this feature, and all the statistics that don't fit in this limit are to be probably saved into a file. But one disadvantage of using a file is that it adds to the overhead of file management. So what we've done in the feature is we have summed up all the remaining statistics and displayed it as a cumulative total. So whatever exceeds the limit is displayed as a single line in the output, which is the total consumption. Now let's look at the API. The name of the function is pggetProcessMemoryContext. It takes as an input the PID of the process for which the memory has to be queried. GetSummary gives you the summary of the output in the sense that it does not display the context statistics of all the context, but only the context at level 1 and level 2. And all the contexts which are further down, further below level 2 are all summed up in the level 2 output. Timeout. So this is the number of seconds to wait for updated statistics. And if the updated statistics are not available in these many seconds, then either display old statistics or just display null if old statistics are not available. Let's look at the output of such a function. What you can see is the listing of all the memory contexts by name. These memory contexts are traversed in a breadth first search manner. You can see various columns which are total bytes, which is total bytes allocated for this particular context. Total n blocks means the number of blocks corresponding to the total bytes. Free bytes are the bytes which are free, and free chunks are the chunks corresponding to the free bytes. Number of aggregate contexts tells you the number of contexts that are aggregated to get this particular line of output. So if the get summary is false, what we do is we display each context individually. So number of aggregate contexts will always be 1 for get summary equal to false. You can see here the get summary, the second argument was true. So the number of aggregate contexts for cache memory context is 98. So this particular output contains the consumption for about 98 contexts, including the cache memory contexts. This one is to demonstrate a particular column called path. Basically, the path column can give you the path to that particular context in the tree. Each memory context are labeled in the breadth first search manner, are numbered in the breadth first search manner, 1, 2, 3, 4, and the path denotes the context's path starting from the top memory context to this particular context. So you can see the context at level 2 will have 2 entries in the path, and the context at level 3 will have 3 entries in the path. This is a customized output which tells you how many total bytes have been occupied by a particular context and all the children under that context. Thank you.
Oh, thank you very much, Rahila. That's a really interesting talk. You covered so many complicated things from Postgres internals, and it's quite a good demonstration of how difficult it is to program in a multi-processing environment where sharing memory is so complicated. It'll be interesting to see if people extend this idea to share more kinds of information between backends for statistics purposes. Adam and I were discussing that when we were looking through the schedule, and the first thing Adam said is, wow, I need to do that for something else, for several other projects. And
exactly. It would be very nice if extensions could register their own callbacks to provide metrics of their own into the subsystem, right?
Yeah. So
the surveys, right? We probably right. Please fill the survey for Rahila, so she knows how she did. You can get socks from this. It's very important for all speakers to figure out how well they did, what to improve, what can be better, and even if it was great, please also say that. Like, it's nice to hear that. Hey, it was a nice talk. Okay.
All right.
Off for a trailer of Livestream 2 now.
Hi, I'm Bruce Vomjan, Postgres core team member and EDB employee. Today I'll be talking about databases in the AI trenches. I've always been curious about how AI worked, and I had the opportunity to do a lot of research to understand the internals of exactly how AI is processed. And as part of that, I was able to understand how databases can be most effectively used for AI workloads. I think that might be the most important thing I'm going to be talking about today. We do have a lot of slides, but it should be an interesting presentation.
Hi everyone, my name is David Rowley and I'm a Postgres committer at Microsoft. And today I'm here to talk to you about what's new in the Postgres 18 Query Planner. And this talk is going to be useful for anyone who's thinking of upgrading to Postgres 18 when it's released later this year, or anyone who's thinking of migrating to Postgres and wants to check in on the latest features.
Hi, I'm Jelte, and I work at MongoDB, and I'll talk about how pgvector can make your analytics queries in Postgres faster and easier to write.
Hello, my name is Heikki Linnakangas. I am going to talk about how we made Postgres serverless at Neon. Stay tuned if you want to hear how do cloud providers run services in behind the scenes.
Hello everyone, thank you for joining my session today. My name is Shinya Kato and I'm a database engineer at NTT Data Japan Corporation. Today, I will talk about Postgres extensions. The title of my talk is Can We Use Fast to Develop Extensions for Postgres? If you're someone who's passionate about Postgres extensions development or curious about how Rust fits into the picture, this presentation is for you.
Hi there, I'm Johannes from Mercedes-Benz R&D in Sindelfingen, Germany. In my session about Azure Postgres security, I'll dive into details how you can make your database more secure. And I will focus about network security and access management. I'll cover all the basics and explain how it works together. So no prior knowledge is required. I want you to be ready to build your own solution in this space.
Hello everyone, myself Palak Chaturvedi. I am a software engineer at Microsoft.
Hi everyone, myself Nitin Jadhav. I'm a senior software engineer at Microsoft. Today, myself and Palak are going to talk about debugging data corruptions in PostgreSQL, a systematic approach. We will explain our experience on handling corruption problems first, and then we will summarize with the approaches to handling corruption cases, including best practices. The attendees can apply these techniques to avoid corruptions at first place and also learn how to detect and recover from the corruptions if it happens.
Hello, I'm Ashutosh Bapat, major contributor to PostgreSQL. I'm part of PostgreSQL contributors team at Microsoft. Today, I will talk about logical replication, which is a relatively new PostgreSQL feature, and it receives a lot of improvements in every release.
Hello, my name is Polina Bungina. I work as a senior software engineer at Zalando, a European e-commerce platform. But I'm also a co-maintainer of partitioning project, and today I want to share with you some insights about how it works, which might be helpful for everyone who is building or operating high availability for PostgreSQL.
Hello, my name is Silvano. I work on Postgres in Microsoft Azure, and I'm here today to talk about .NET and Postgres as the next open source application development stack for your solutions that can run on your on-prem, cloud, mobile, and many other platforms, and interacting maybe with the next-gen AI models that Azure is providing.
Hi everyone, my name is Nato Alonso Portillo. I'm a Principal Technical Product Manager in the Azure Database for PostgreSQL team. In this session, I'll be introducing a fantastic feature in which we keep investing to extend its scope and evolve its functionality. You're interested in this session if you're a system engineer, a developer, or a database administrator who is struggling with performance issues.
Great lineup. And if you missed the live stream too, don't worry, it's recorded. You will see all the talks with transcriptions, with hand-tuned transcriptions, not like automatic machine Postgres shenanigan translations. There are actual people that went over this, checked every word, reached out to speakers to make sure, like, hey, what did you mean here? Which I think is amazing in itself. It's a lot of work, and it then shows in the production quality and the translation quality. Next up, we have Jan Karamans from Cybertech. Jan will talk about securing your PostgreSQL streaming replication in the context of disaster recovery and essentially making sure that your data doesn't go away. So I'm looking forward to the talk. Let's hear it.
Hello and good day. This is Jan Karremans. I head up sales in Cybertech, but I still think I have sufficient technical background to take you along on an interesting journey on securing Postgres with streaming replication. It is one of the hidden in plain sight cool features of Postgres that might just help you save the day. So let's start with the presentation. As I said, I have been in sales at Cybertech for quite a few years. Even longer, I've been active in databases, longer than I care to remember, almost 30 years. And the interesting bit is that the last 6 years, I've also been able to combine Postgres as a community-governed open source technology together with Kubernetes, which is also an open source community-governed project, which, the combination of both is super, super interesting. I work for Cybertech. We are a pure play Postgres company. This is a lot of marketing, blah, blah, but I think, it's interesting just to have a quick peek on, pure open source Postgres, working with Postgres, and why that is so very important. If you want to know more, please go to our website and you will find a lot more. Core thing is that Cybertech is focused on Postgres. It's in the heart of what we do. And we want to contribute to the community, we want to contribute to the project, and we want to help businesses succeed with Postgres. One of the things in that is basically streaming replication. I think it is one of the, everybody knows it, most everybody is using it, but not everybody has really thought a lot about it. And I think it's a very interesting piece of technology that, I want to highlight really in this presentation. What is streaming replication? Why does it even matter to you? And why should you care? The world runs on data. Data is, we've heard it all, the new gold. So that means that every organization, every entity, everything that you do is really built up and around data. And if you start missing pieces of this data, if you are starting to miss, just a change or a bit of data, we all get into this very scary situation that even though you trust your system, and if you ask something of the system, you expect to get a full and correct answer back, if there is actually these kind of things happening, you just might be in for a disaster, right? Data in databases, I feel, lives in transactions. If it's just the pure stored data, you wouldn't have to put it in the database. You could just write it on a piece of paper, right? So change is the default. The value of the data is in the fact that it can actually revolve and stick to, the changing situation in the world. What we want to do is secure these changes, make sure that we don't miss those specks of changes. We want to be able to replay these changes inside the actual system you're working on or in an external system. And you want to do this, I've called it dead or alive, or dead and alive, actually. You want to record changes and have them be stored as a fixed something. But you also want to do this alive. You want this to, live on in another system. So these things help ensure that, the data, the things that you're working through are captured and made sure. Streaming replication inside Postgres is basically built by Simon Riggs. Everybody knows and respects Simon, and unfortunately he's no longer with us. And Simon told me, please be aware that protocol foundations that are necessary for streaming replication were actually created by Hans-Jürgen Schönig from Cybertech. So actually, streaming replication is built on the technologies that these both gentlemen have created for Postgres, for which I am incredibly grateful, obviously, because otherwise we wouldn't have streaming replication. These changes live in the transaction log that gets created on the primary system. A transaction comes in, it gets processed in a transaction engine, it ends up in the wall log or the write ahead log, and then from there, persists in the data files, it persists in the transaction log, etc. These changes are also available at an IP endpoint, the blue antenna in this graph, and can be picked up by a replica database, which is a secondary database, a complete independent Postgres cluster living somewhere else that actually listens to these transactions, receives the transactions, writes it to its own wall log, and persists it in its own data file. So in this setup, you actually have changes that are happening on primary, getting replicated to the replica database, as the name so fittingly says, and gets persisted there, right? Characteristics for streaming replication, it's binary compatible. That might sound trivial, but there are a lot of use cases that actually require a standby or a replica database, a copy of that database that you're using for backup or disaster recovery purposes, to be binary compatible with a primary. So it's one-on-one the exact same system. If you look at other technologies that you might have looked at or heard of, like logical replication, in that case, the databases aren't binary compatible anymore. So those are things to take into consideration. Streaming replication works out of the box. I vividly remember my very first Postgres cluster that I set up and thinking, hey, it's so easy to add a replica database to a primary. Well, yes, it is. It is rock solid, super secure. This technology has been around for a very, very long time. Very many organizations use it. And if you're not using it today, there is no license restrictions to add a second node to your Postgres cluster. So please do that. Set up streaming replication, go play with it. There is, a world of interesting things to gain here. So, that was the basis of what is actually streaming replication. So if we now take this and start translating to, what does this look like in reality? It starts with, this very single lonely Postgres cluster. It lives, in, God forbid, but you might even have, transaction logging not enabled, or, having it disabled, which makes the database very fast, admittedly, but please don't let anything happen to it, because if you're not even logging your transactions in a transaction log, if your database crashes, it won't start up anymore, because it has no ability to come back to a new safe state, right? So the first thing you want to do is actually enable transaction logging. But then still, there is this one single Postgres cluster, and that really makes not very much sense from a reliability perspective. You're not using that fantastic technology called streaming replication that is actually available for you to play with. So one of the first things you want to do is either start skipping WOL files. These transactions are written in so-called WOL files, write-ahead log files, and you can actually copy those and make your own sort of running backup of it. Cooler even would be to add to the next level, which is going to an entity where you stream transactions to another location. So that builds sort of a backup that is continuously being added on as transactions happen in the primary database. That at least gives you the ability to do point-in-time recovery in a much finer grained fashion than you would do with WOL file copying, because if the WOL file isn't full and you're not switching to the next one, it's not copied to the safe location. So if you have a disaster happening exactly in that middle point, you're missing transactions, and you don't want that, because Oracle lives on data and you don't want to miss a spec. So we go to a world where we have a primary database and we have a replica database. Transactions written in the primary are then streamed to the replica database, are applied in that replica database, much as we saw in the little graph earlier on, right? So that at least ensures that my second database is in the same situation as my first database. If something happens with my primary node and it disappears, I can simply evolve that replica database, promote it, if you like, to be a primary database. One of the things here that is super interesting is that you can do this asynchronously and synchronously. Asynchronously would mean if something happens on a primary, it is copied to the replica, and at some point it will be taken up by the replica, but you don't really care. The focus is on the primary, just keeping working on the primary, and these transactions will be streamed to the replica anyway. The other mode would be synchronously, and synchronously would say, if something happens on the primary, I want to have confirmation that it also happened on the replica, so that if something happens with the primary, I am absolutely sure that that also happened on the replica, so I don't miss data. That sounds very cool, but there are dangers, and I am biased in this case, so you have to do your own thinking work. My personal bias is I would not really want to use synchronous replication too much. That has to do with the fact that if you write something to a primary and you're going to wait, remote write on or remote apply on your replica to say, I have either, consumed the change or actually, as in remote apply, completely made sure that it's also persisted on my replica database. There is time involved. There is time involved to get the transaction to the other side. There is time involved to get it processed locally, to get it made consistent and made durable. And all of the time that replica is working, your primary is waiting. If there is one thing which is key in the world of database transactions, it's the triple P, right? PPP, performance, performance, performance. What are you going to have if you're waiting? You're not going to have performance. My feeling is that, the Postgres streaming replication fact, the systems these days are so incredibly reliable that you can rely on asynchronous replication to be sufficient. But again, this is my bias. Do your own research because it's very important. So what you would get is then go to a primary and replicas where, one set sits in one data center, the other one sits in the other data center. A good idea could be to have the primary and the replica which sit in the primary data center to have a synchronous connection and then stream the other transactions asynchronously to the other data center. Why? Because the latency in that first data center where the two nodes are sitting very closely together will probably be very low, and you will probably get away with the performance impact of that synchronous replication. But the transactions that have to go all the way to the other side of the city or the country or the continent or whatever, you don't really care. Those transactions will eventually end up in that other data center and get persisted there. That's not as important. Another way you could do, and this is what we call the maximum availability architecture, is start playing with synchronous and asynchronous, in this case with synchronous replication, but there are some tunable things in there as well. So what you could do is, I am building a primary and I'm streaming synchronously to replica locally, and I'm going to send the transactions to another data center, a second or a third data center. And what I'm going to say is, I have 3 synchronous standbys, S1, S2, and S3, but I'm going to only wait for the first 2. Probably the one which is sitting next to the primary will be the first one, so you got one check. And then you're going to wait for the first one of the 2 remote ones to say, I have committed the transaction on my side. We'll also send that back, and you don't care about the third one. The third one will still transact, and both the 2 replicas on the remote side will also stay, in sync, but you don't care about waiting for the synchronicity of it, right? So this could be something where you could start playing. One of the things we're looking for in the government software, the governance software around it, is that you can also start playing with how many synchronous standbys automatically, and reconfiguring actually going from synchronous standby to asynchronous replication, just for playing to get maximum availability established in favor of the synchronicity. This is a concept that is derived from other technologies and might actually in some cases make sense. Another cool feature that we can also play with is cascading replicas. So in this case, we have a primary and a replica, a synchronous replica. Both the synchronous replicas, so the primary and the first synchronous replica, have asynchronous replicas in that same data center, but that replica is also streaming replications to the other side, or the transactions to the other side, where you have another mechanism with the primary and a standby happening as well. So this is basically an endless cascading game that you can play with, where you can actually start building up how you build out your replication sets. There are a lot of more tools around streaming replication. I've just highlighted 3, which I think are super important. HA proxy for ensuring that if you have a primary and a replica, you can actually play with that, where your transactions will end up. Patroni as a tool for governing primary, replica, failover, switchover. So that's basically a tool that sits on top of streaming replication and automates streaming replication. And finally, one that I wanted to highlight is pgbouncer, which is a connection pooler. It isn't necessarily tightly linked to streaming replication, but it allows you to play with, if I've got 1,000 systems coming into this one database, actually build a queue and play with that a little bit. So that would be, streaming replication and how you could work with that. Then, what does it actually mean? And I think we talked about this already a little bit, right? Streaming replication is a toolbox. The toolbox that gives you the creativity to build exactly that form of high availability, that form of disaster resilience in Postgres that you would need. The technology is rock solid, super secure. With it, you can build, your own data protection mechanism that, holds no boundaries. With it, what we saw, you can have you can secure a single Postgres cluster to building really globally dispersed data protection strategies. So this is one of the coolest things about streaming replication for me. It's so easy, it's so incredibly logical, but still so super powerful that you can do so many different things with it. And just talking about Postgres itself a little bit more, and this is derived from streaming replication in some shape or form. Ans Hasma, colleague of mine here at Cybertech, has put some things together that I wanted to quote because I just thought it was amazing. Postgres ecosystem, it will solve anything, right? It has been around for over 25, almost 30 years, and everybody has been working with it. Recently, I stumbled over a list of database systems derived from Postgres. That list alone is arm's length, right? So anything that you would need Postgres to do, somebody else will have thought about it. Somebody else will have built something for it. So, if you would do an internet search, Postgres probably has a solution for that. And it doesn't really matter. You will still get the job done in that sense, right? So basically from there, just use Postgres. You don't have to look at other systems. Use it until it no longer works, right? Then you get into optimizing Postgres, finding that one extension that might just do what you need it to do, right? And, it will just do the job. Only then you will get to a point where you say, perhaps my workload is so super special that I need, a special purpose tool to do what I needed to do, right? The chance that you will get to that, and if you're lucky, you will never get to that step number 4, right? Because if it goes from graph, document database, AI these days, think about any crazy things, Postgres will have the solution. Postgres will just do it, right? So to summarize that, Postgres is the best because it's good enough for the task you didn't know you had. And I thought that was a very powerful statement. And, basically this puts me at the end of this incredibly quick talk here. There is dozens of things more to talk about streaming replication. I just wanted to highlight these few things. Cybertech is not alone in the world. We're part of the Open Source Business Alliance. We're part of PG for Business. Proud contributor to Postgres and founding member of the Open Alliance for Postgres Education. Coming to that, as you watch this presentation, the Open Alliance will have been is live. And if you want to find out more, you go to oipg-edu.org and just find more or scan the QR code here. Final reminder, PGD Austria live again, September 4th, 2025, Schloss Schönbrunn in Vienna. Tickets are live, Call for Papers is open, Call for Sponsors is open. Very well recommended and very much endorsed.
Thank you very much, Jan. And Ants, that's a great algorithm he has. I actually remember sometime in the late 90s using Postgres 6.5 before it had the transaction log. And you'll be amazed to hear that it ate my data. But the transaction log and the streaming technology has been with us for a long time now. It's, foundational stuff. And great introduction. If you want to complete the survey for Jan's talk, Securing Postgres with Streaming Replication is the title. And now we're going to go to a trailer for Livestream 3. If you missed it, you can catch up with all of the speakers from Livestream 3. And here is the introduction trailer for that.
Hi, I'm Bruce Vomjan, Postgres core team member and EDB employee. Today I'll be talking about databases in the AI trenches. I've always been curious about how AI worked, and I had the opportunity to do a lot of research to understand the internals of exactly how AI is processed. And as part of that, I was able to understand how databases can be most effectively used for AI workloads. I think that might be the most important thing I'm going to be talking about today. We do have a lot of slides, but it should be an interesting presentation.
Hello, so I'm Chris Ellis, the head of technology at Next Team, and I'm going to be talking about fun with UUIDs. So this is a talk about the kind of pitfalls and advantages of using UUIDs as primary keys instead of just standard database sequences. So this kind of talk is really for any kind of application developers who might be working on multi-tenanted, say, SaaS applications, where the advantages of using UUIDs will probably be out-benefiting the kind of problems that they cause.
Hi, I'm Karen Jex, Senior Solutions Architect at Crunchy Data, and today I'm presenting Managing Postgres at Scale, Challenges, Tools and Techniques. So I'm going to be talking to you about some of the things that you might encounter as you work with Postgres at scale, whether that's managing huge databases, whether it's managing many databases with large numbers of users or high transaction throughput. And we'll look at some of the things that you can do, some of the tools that you can employ to make that easier. So please stay tuned.
Hello everyone, my name is Alexander Kukushkin and I work as a principal software engineer at Microsoft. I'm a Postgres contributor and today I'm going to talk about synchronous replication in Postgres and some myths and truths about it. If you are application developer or DBA, this talk might bring very interesting insights about these topics.
My name is Varun Dhawan. I'm a principal product manager here at Azure Database for Postgres team at Microsoft. Me and my team, we work on building Azure Database for Postgres Flexible Server, which is our flagship managed server offering. If you are using Azure Database to post a flexible server or planning to use it, this will be a great talk, to stick around. So see you there.
Hey everyone, I'm Jimmy Zelensky. Today I'm going to be talking about implementing strict serializability with pgexact. If you're interested in correctness and the internals of Postgres, this is the talk for you.
Hello everybody, I am Krishna Kumar. I work as a group engineering manager at Microsoft, working on PostgreSQL open source as well as the managed service side of things. Today, I bring to you a talk called PostgreSQL and Linux kernel interactions. In this, you will learn a lot about the internals of how Postgres interacts with the Linux kernel and how to look at this, how to debug this, and a lot more. Welcome and come watch my talk.
Hello everyone, my name is Sarath Balajapalli. I'm a Principal Engineering Manager at Azure Postgres team. Today I will be talking about Postgres partitioning challenges. My talk would be useful for database administrators and database developers. So let's get started.
Hi everyone, I'm Neeta Goyal, CEO at Newt Global.
And hi everyone, I'm Sandeep Rajiv. I'm the Sales Director at Newt Global.
Today, we will be talking about migration considerations to go from Oracle to Postgres. If you are considering migration from Oracle to Postgres, this talk is for you.
Hey everyone, my name is Abe, and today I'm going to be talking about building intelligent applications with graph-based RAG on Postgres. If you're someone who's already built a RAG application or want to learn more about making your RAG apps more accurate, this is a great talk for you.
Hi everyone, my name is Toyo Valley. I'm a Microsoft MVP on Data Platform. Today I'll be talking about Azure Database for PostgreSQL, 15 essentials for compliance and security. If you are using Azure Database for PostgreSQL, doesn't matter if you're a veteran or if you're new, you should be listening to this talk.
Great lineup again. And don't worry if you missed it. You can watch the recordings with good captions, handmade captions like we discussed. All of the trailers will be available. And we are arrived at our wrap-up. I don't know why I said that. So today you have been hosted by Thomas Monroe and me, Adam Wolk. I hope you enjoyed this. But this event has been many more people, most importantly, all our speakers. We are not going to name people because there's too many to single out any one of them. You have to watch all of them. And I'm distracted by the hallway track. Sorry for that. It's been a silent hero of the event for me, following the track. And you, Thomas?
Yeah, and thanks to everyone who participated in that, which is ongoing.
We had a great doc selection team. Melanie, KK, Daniel, and Claire. Do you remember how many submissions they had to go through?
I don't know.
I think it was over 200, right? Like 220 or something like that. That's amazing amounts of work. And year to year, there's more. So, by the way, if you're a first-time speaker, a second-time speaker, a repeat speaker, feel free to submit next year. Especially if you're a first-time speaker, we love to give people a first-time chance.
Yeah. Huge thanks to the organizing team who make this happen every year. Bilge, Alma, Abe, Aaron, Jeremy, Linda, Pooja, and Teresa. Thanks very much for all of your work. And a lot of other crew behind the scenes.
Yeah, especially those that stayed overnight with running this with all of us. We deeply appreciate the work put into the invisible work that makes all of this happen.
Yeah,
and
across many time zones. So.
Exactly.
Yeah,
exactly.
It involves staying up all night to make these things work. So yeah.
We had a range of hosts this year: Claire, Flor, Boris, Melanie, Derk, Thomas, and myself. We thank each and every one of you for taking the time and running the event with us. So what's next?
Yeah, you can still jump on the Discord and talk to some of the speakers who might still be around, and other people in the community, people who've been part of Posette 2025. The talks are on YouTube. There's all 4 live streams. Should be up. I'm not sure when these ones go up, but with high quality captions, subtitles, and translations. And of course, as we keep saying, you should provide feedback, fill in the surveys, and you can get swag.
Yeah, and most of all, speakers, especially those that did this for the first time, get to learn what to improve, or get a confidence boost. Like, hey, that was nice; it helped me, and that's great to hear, and worth the the couple of minutes that you will spend filling this out.
So the conference is brought to you by the Postgres team at Microsoft, and it's open to all, and we hope that you enjoyed it.
So thank you for joining the live stream. We really appreciate the time all of you took to be here with us.
So if you're interested in participating next year, if there's something you want to tell us about Postgres, what you're doing with it, or anything about the Postgres ecosystem, watch out for the call for papers. You can follow,
You can essentially follow us on any of the popular media platforms. Like, you can join the Discord channel, follow us on LinkedIn, X, or Twitter, whatever name you prefer, Blue Sky and Mastodon, if you're into federated networks. There is an ultimate guide to this conference that you can find under the URL.
Yeah, some of the big numbers: 18 Postgres core talks, 2 amazing keynotes, 12 ecosystem talks, and 10 Azure database for Postgres talks.
Which is something I really love that we managed to do, right? Because yes, this is a conference hosted by Microsoft, but it's mostly a community event, right? We're not making this like an Azure event. We actually want to see many people come in and talk about open source PostgreSQL and what you do with PostgreSQL and your experiences with the project. We had 11 talks in Livestream 1. We won't go over the list of people in all the talks. You can find them in the ultimate guide. But just briefly going over the slides, you can see the lineup is very strong. I believe you will recognize many of the people in all of the live streams. And some great keynotes from Bruce. And we have upcoming events in 2025. Do you want to cover this, Thomas?
Yeah, so there's the Swiss PG Day taking place in Rapperswil in Switzerland. That's in June. That's not even too far away, a couple of weeks away. There's PG Day in Mexico, in Toluca. There's Hyderabad Postgres Days in India. In both of those are in August. There's PG Day Austria in Vienna in September coming up, and those last two both have their CFPs still open. So if you're interested if you're in the region and you're interested in proposing a talk or interested in traveling, yeah, you better get on it because the CFPs close this month. There's the UK Day in London in September, PG Lowlands in Rotterdam in the Netherlands, PG Day Napoli in Italy, and one that's close to my location and close to my heart, PG Down Under, which is going to be in Sydney, Australia. The Naples and Sydney events both still have their CFPs open. I'm actually on the talk selection committee for PG Down Under, and I would love to see your proposal.
There's even more. PGConf New York City and one of the biggest ones, pgvector, which I think breaks records each time. I don't remember how many people was it last year. Was it 600?
I think it's more than that. I'm not sure. I don't want to say a number and be wrong, but it's big. It's a bigger number than that, I think. Yeah.
Yeah, it's huge. It's huge. And somebody, I think, on the live stream yesterday said that there were over 800 submit papers for last year. So it's a big conference. Like you really need to go there and meet everybody.
I went for the first time last year, and I absolutely loved it. Highly recommend that conference.
Okay, we went over this slide. So we can break down a bit of what we had in the like in general. We had 18 PostgreSQL core talks, like speaking about core PostgreSQL features. 12 ecosystem talks. 10 Azure database for PostgreSQL talks. And most of all, we have swag. Thomas?
Well, I think these socks are actually really quite special. High quality socks that they're well worth filling in a talk survey for. So yeah,
they usually go very fast when we are on conferences, especially if Charles goes and does a keyword tagging everybody to get socks. Then we have to scuttle to the stand and expose additional ones as the crowd is going our way.
Yeah. All right. So you can get to posetteconf.com to find the talks. From there, you can find your way to all of the recordings and everything. There's also a YouTube playlist you can get to directly on aka.ms/posette-playlist. Posetteconf.com is pretty easy to remember those. So yeah, easy to find. So there's this podcast, Talking Postgres, which I highly recommend. It's run by Claire Giordano. This came out of this conference as a sort of a lead up to the conference, and I think it's developing into a sort of an oral history of the project, interviewing all kinds of people who are involved with the project in different ways and finding out how they came to be involved in Postgres and how they, what their story is, and highly worth a listen. Very good while you're out walking or something like that. You should check it out if you want to hear from all sorts of people in the Postgres world.
I absolutely agree. That's my go-to favorite for when I'm driving. Perfect. So, like you mentioned, here's a list of people that were on the podcast so far. You probably see a large overlap with the speakers. So that's a good way to know more about the speakers that you enjoyed hearing talks from. And that actually brings us to the end of the live stream, to the full recap. Please remember to do the surveys. It helps all the speakers and everybody involved. And yes, you can get socks until they run out. But most importantly, it's very nice for the speakers to show, what can be improved, what went well, what went bad. It's a few minutes that all speakers appreciate you doing.
Maybe next year you'll be a speaker and you'll appreciate the feedback.
Exactly. Okay. So with that,
thanks very much for tuning in, everyone. Yeah.
And thank you, Thomas, for co-hosting with me.
Thank you, Adam. It's been fun.
Yeah, totally.
All right.
Bye.